EMC Power Store appliance, but the steps can be applied to almost any VMware environment. Finally, enjoy the rest of the VMworld presentations. There will be lots to come on new Kubernetes features and capabilities in VMware, specifically around vSphere 7.0 features. This concludes this vBrownBag session for today. Thank you very much for attending and have a great day.
Hi everyone, my name is Karol Boguniewicz. I'm an expert and engineer from VxRail technical marketing team at Dell Technologies. The topic for this session is vSphere and VxRail REST API. Get started in an easy way. And if you open that, then I assume that you're interested in RESTful APIs. And that's why I wanted to make it more practical for you. Instead of preparing slides, I thought that such a short time allocated, I will show you an extensive demo instead. I'd like to show you three main things. First, how you can start your API journey by leveraging an interactive web-based API documentation. Second, how you can use these APIs from different frameworks such as scripting with PowerShell in Windows environments and configuration management tools such as Ansible on Linux. And finally, how you can consume these APIs virtually from any application in any programming language. Sounds interesting? Well, let's dive deeper into that. So let me start the demo. So probably the easiest way to start your API journey is to use the interactive web-based documentation for that. We're leveraging here a Swagger framework, which is an open framework for API development, very popular in the industry. And we've designed those APIs in the way that they are complementing vSphere APIs. And you can just go to this URL from the VxRail manager and you can choose, there are 12 different groups of APIs available in the 7.0 version. I'm not going to talk about all of them, just a few of them. So if you choose the spec for LCM, that will provide you with the functionality for the automated lifecycle management, which is a huge differentiator here with value add. If you go to support, you can change the support features such as support account or maybe remotely collect the log bundles for the system. And if you go to the system, then you can collect very useful system information, including health, etc. To start interacting with that, you just click one of those API calls and immediately it expands and provides you with the possible response codes like 200, 400, etc., and also the example values that these APIs would return. And you can also check the model. This will show you the data model that is used by the API, so you will know what kind of information that you can expect in return. To try it, just click Try It Out button and execute. This one doesn't have any parameters. And you immediately see here that we got code 401, that's an error message that provided vCenter credentials are not valid. And that's actually a good thing because we haven't authenticated against the system yet. So that's a good thing that it prevents you from authorized access to the API. To fix that, I'm going just to authorize using my vCenter credentials. So administrator and password. And you can check the authorization status with the lock icon, which is now closed. When you try that again, we can see there's a corresponding curl command URL, and right now the response code is 200, which is success. You can see the response in a JSON format, very useful information about the system VMs, health of that, how many hosts in the cluster, etc., etc. And a typical scenario, if you'd like to manage the infrastructure remotely, we need to collect some inventory information. And you can do that with the hosts API available from the host category. You can check the value model. We can try this API. Again, we can see the returned response, and this provides a lot of useful information on all the hardware components in the system. In a similar way, you can consume vSphere APIs. Also, the same approach, web-based interactive documentation. Just log into vCenter, go to the Developer Center, and then you can choose the API. In this case, we'll interact with vCenter, so choosing vCenter API. And for instance, to get a list of VMs on the system, I will choose the first one, get REST vCenter VM. I can provide multiple filters to filter the output based on names, folders, data centers, etc. Maybe even a power state of VM. Well, for the simplicity, I will just use the default. Let's execute. And immediately you will see also the corresponding curl command and also the response. This time it also includes the information about the data model use. And let's take a look at this CentOS 7 VM template machine. Because in a typical scenario, you're going to have a golden image from which you will create multiple VMs. You will have a pre-installed operating system with all security settings and software. I've copied the ID of this VM because I'm going to now clone this VM from this template. There is an API call with the action clone. I can populate the parameters using the data type, which is shown on the right. Now, as a source, I will provide this VM ID that I've just copied. Let's immediately turn it on. And I'm not going to modify too much in this clone. So maybe let's, instead of using default name, provide a specific name for this demo. I'm going to change the placement. It will be the same location as the template itself. Very simple, clear example here. I'm going to execute. I can see the curl command. I can see the response. In this case, it's an ID of the newly created VM from this template. I can check that from the VMs and templates view. I can see that this clone indeed was created. It has been powered on and available. So that was a very quick start with the interactive web-based documentation. What if you'd like to start your API journey using the available automation frameworks for scripting, etc.? Well, the API cookbook will be handy for you. You can go to that. It's available on the support site. And let's see some very simple example. Let's check the system status. We did that already from Swagger. We're going to do the same. And you can see that we have multiple examples here in curl, in PowerShell and Ansible. So let's start with PowerShell. PowerShell is now available on most of the modern Windows systems, a very popular scripting framework. But you can also use, of course, the REST-based calls, but it's better to install the necessary modules because it just makes things simpler. In this case, I've already installed the X-Ray API, and you can see that it installed multiple namespaces corresponding to those different API groups that I shown you from the web interface. So let's copy this example. Let's copy the DNS name, in this case, of the VxRail manager. Let's provide the authentication information again, and we receive the same output that we see from the web-based interface. To make it more human readable, I can provide the convert to JSON commandlet, and now it's formatted for me. I can check the list of all the commandlets which are available in this module with the get command and get some help about specific commandlet using get help command. This is really the same experience that you get from Power CLI if you have ever used that. So let's take a look. That you can do similar things with the Power CLI, but we will talk to the software stack that is built into the system. So I imported the Power CLI. Immediately I got some getting started information. I've listed all of the commandlets, and there are currently hundreds of them, almost 900 automation commands. When you combine that with what we provide with VxRail, you in total get more than 950. Very powerful. Now let's check the Ansible example. So I've installed the CentOS system here. I can check the Ansible version installed. I already copied this example and changed the environmental variables, and I can run this playbook. So using this different framework, this now configuration management framework, I get the same result. I can check the system information. Now let's take it further. what if you'd like to consume those vSphere and vXtrail APIs virtually from any application, any programming language? Another tool, Postman, will be handy here. VMware provides several examples on how you can consume vSphere automation APIs using Postman through the collections. They are available on codevmware.com. I've already imported them on the system. You can see them here, vSphere automation REST samples. You can browse through them, and for instance, you can check VM create with details, which is an example how to create a new VM with a lot of detailed parameters from REST APIs. In the body tab, you can see the past parameters that you need to provide. So I wanted to show you a quick trick how you can use the same approach, but with the vXtrail API. When you go back to Swagger, when you use this hyperlink there, when you save this file, it actually saves the API specification, which you can import as a collection to Swagger. So you can use that in the same way. So I'm going to import that with default settings. I'm importing that, and immediately I have a folder with a new collection, the vXtrail RESTful API configuration documentation, and that contains all the same API calls that were shown in the web-based interface. There is one more variable that you need to set up in the environment here. It's base URL. You can copy that variable from the Swagger. And again, we need to authorize against the system first to provide the vCenter server authentication details. I'm providing those here. And now when you send this call to the vXtrail manager, we get the same output nicely formatted in JSON format. Now, if you'd like to do that from other programming languages, this is where the code functionality is helpful, because it can generate code snippets for you in different programming languages, including C#, Java, JavaScript, Node.js, PHP, Python, and many, many more. So let's try the Python as an example. I'm going to copy this automatically generated code, paste that into the text editor. I'm going to add one additional parameter, and this is really just to disable the check of these certificates. And immediately I can get the same output from the Python that you could see in the previous examples. This is really powerful. So let's recap. In this session, I walk you through how you can easily start your API journey and how you can use vSphere and vXtrail APIs together from the same tools to get more value. We discussed how you can explore and interact with these APIs from the web browser, PowerShell, and other automation frameworks. And finally, I've shown you how you can integrate with these APIs from virtually any application in any programming language using code snippet generator in Postman. I hope you found it interesting. Please give it a like if you like that, and feel free to reach out to me with questions. Thank you for your attention, and have a great virtual VMworld.
Thank you for taking the time to look at to view my vBrownBag session that I'm going to record. It's how to use vRealize operations as you're monitoring single pane of glass. I work for Select Medical, and we're located in Mechanicsburg, Pennsylvania. I am a vExpert for 2020, and if you look at my slide deck there, I do have my Twitter handle and also the address to my blog if you would want to reach out to me after you view this. A little bit of my background. I've been using the ESXi for quite a few years, vRealize operations, for over 6 years. Create a lot of custom dashboards, reports, alerting. Been using the True Visibility Suite. I also do a lot with vRealize automation, so I'm going to show some demos, that whole single pane of glass, how you can integrate the two together. And just real quick with the V community, I've been involved since like 2013. Started by just going to some local vMugs, and then I thought I wanted to give back a little bit, so I've done some presentations at some HVC events. I've done a power block, and Also talked to some little hacks. And if you haven't gone to a little hack, those are really good. You should try to get involved locally if you can. So to use VROPS as your single pane of glass, there's a lot of really good built-in stuff right out of the box. Some really good dashboards, alerting, and reports. And then once you become more familiar with it, start creating your own dashboards and your alerts and start looking at super metrics. And then you can use it for troubleshooting, right sizing. If app teams ever come to you and say, I need more CPU and memory, there's some really great dashboards to get the proper size of your VMs, or to even show costs to your managers. If somebody says, hey, I want to move this to the cloud, there's some really good dashboards on showing the costs on-prem versus the cloud. So that's, I keep saying that single pane of glass. I mean, there's so many uses with VROPS. And then to start extending VROPS, instead of just using everything that's built right out of the box, they have what they call management packs. So if you go out to marketplace.vmware.com, there's some that you can get, and that'll start expanding the capabilities of VROPS. Some examples are some of the storage companies like HP or EMC have some management packs. So not only can you monitor your hosts and your VMs, but now you can start getting a lot deeper into your SAN environment. So that's, that single pane of glass. And what really made me think about the topic of my presentation is when I started looking at the text display widget. You can actually, with that widget, you can link to internal URLs, external URLs, website widgets. You could show weather maps. If you have a lot of SaaS applications, a lot of them have like a status website of how well they're doing, and you can link to that. And what you can't do with it is you can't alert off of any of that data. It's really display only. But my use case was to create VROPS to be that single pane of glass for our environment, and just to show data from many different sources. Here's some examples. I said I do a lot with VRA also, which is vRealize Automation, is I create some websites that I link to with VROPS that show our server builds, or if we're going to decom a server, or we let app teams do snapshots. So I have these dashboards that let us see what other teams are doing. So, it's that one place to go for monitoring, and you can use it for more than just the data that is collected out of vCenter. So here you can see like our server builds, I show the server name, the IP, all that information right in that dashboard. And the way I do my automation is most of it is with PowerShell. So like for doing server builds, when it's done, I create a static web page that I put out on a web server, because I store the data into a SQL database, and then I create this website. And it doesn't matter what the web server is. If you're a Windows web shop and you want to use IIS, or if you want to use any other kind of web server, it doesn't matter. And I kind of got the idea because if you go to my blog site, I've been using Hugo, which I've been pretty happy with. And what I do is I take all those pages I create with Hugo and I save it to my GitHub repository, and I use GitHub Pages to display that. And that, when I started using that, it's like, that'd be a great way to do VROPS. So that's what I do. And what management does in our environment then is they're always going to VROPS as that single pane of glass to see what we're doing with automation. So it's that nice little integration. Then with VROPS 8 and VRA 8, they did a really good job right out of the box that you can integrate the two together. So if you do a deployment, and let's say you give users access to only VRA and not VROPS, you can still integrate those. And if you look in there in my slide deck, you can see I'm showing the performance of the VM. So there again, it's always going back to that one single pane of glass that you can pull in all the information. And thinking outside the box a little bit with the text display widget, we have two different data centers. And one of the things I thought would be kind of nice to show is the weather from each. One is in Pennsylvania, one's in Texas. And then like for Pennsylvania, I even show the radar map. And that's all within VROPS, that you don't have to leave VROPS if you're in there monitoring your performance all day long. And I just thought that was a great way to show that, because if you display this on, let's say you have a NOC center and you have a whole wall of TVs and you want to be able to show the people inside your NOC, hey, this is what the weather's like outside, because most NOCs that I've been in don't have windows, and it's kind of thinking outside the box a little bit of what you can display. Ever since everybody's on my team has been working from home, we're really big users of Zoom. So we use that for video chats and chats. So Zoom has a status website. So there again, I use the text display widget to link out to Zoom, and it shows the status. Just this past Monday, Zoom was having some issues with some people weren't able to join some video conferences. So some of my team went to this dashboard that I have, and they immediately seen that, hey, there's some alerts that Zoom's saying there's issues. So, you know, it's always that single pane of glass. I keep saying it, but, you know, try to think of that's where you go to do monitoring and check performance. You know, I'm even showing an example there of AWS. There's a lot of SaaS applications that people have, and as long as they have a status page available, you could look at showing that. And there again, you could even show that in your NOC. You know, everybody's working from home. One of the things I didn't always know was when were the people actually working on my team, if they were taking a day off. So our developers internally created a web page that shows information from Kronos. So they sent everybody the link, and I'm like, man, that would be a great thing to include in the VROPS, since we're in there all day long monitoring performance, is to create this link. So you can see there, I can go out at any time and see who's working and which days. And when I talked about right sizing, you know, in addition to monitoring, you know, if an app team says, hey, I need this much CPU or this much memory, after you're monitoring your VMs for a while, it tells you what they should be, you know. So if they're asking for a lot, you can say no, or maybe it's even the opposite. Maybe they don't have enough CPU and memory, and that's why they're complaining that it's slow. So there again, to use that single pane of glass, now you're also using it to set up things correctly in your environment. One of the new features in version 8 of VROPS that I really like is the troubleshooting workbench. So, you know, you're monitoring, you're kind of seeing how things are, but then to go out here and do your troubleshooting. Here you can see all the different layers in your stack, and I really like how they do the red, yellow, green. You know, if VM is having issues, go and look at this right away and see where your issue. If you see red, you know, that's where maybe you should start looking at first. If things are showing green, you know, don't spend time in that area. So there's also many ways to show this information to your users. You can set them up as a user that they would sign into vRealize operations directly. In a NOC environment, if they sign in as a specific user, what you can do is give a list of which dashboards that you would want to display, have them auto-rotate, and what's going to display next, and set a time on there. If you have workspace 1 in your environment, you can create catalog items that are linking to dashboards. And if you just want to send somebody a quick link by email, you could do that. And if you look at my slide deck, when you create these links for people to see outside of VROPS, you can even set a time, and you can say it's good for 1 day, a week, a month, or never expire if you're doing it on like a company portal or something. So I'm also showing that let's say there's one dashboard that you created that you have this corporate portal that's already in place, and they're like, man, I'd really like to show that data. You can take the embedded information, and that's what I'm showing, and include that into other systems. I mean, everything I'm talking about is bringing data into VROPS, but you can do the opposite too if you really have to. Here's what it looks like in Workspace ONE. You can see like where I work, we give a lot of links to all the VMware products, even some products that aren't VMware. And then this makes a nice little area that everybody comes to that you don't want to set them up as a user, but you still want them to see the dashboards. You can do that with Workspace ONE. And then what you can do is set up what they call categories. And I have a category that's called dashboards. So I take all my VROPS dashboards so to quickly see which ones are dashboards, groups them all together nice. And this would be like if you're in a NOC environment or even working from home sometimes, I have an extra monitor that I'll sign in and actually have like a NOC type environment in my house that you can say, display this dashboard, and then, do the auto transition, turn that on, say, keep it on the screen for 180 seconds, 3 minutes, and here's what to display next, and just have these screens. So if you're on a NOC and you have a whole wall of screens, you can kind of set up some really nice, if you don't have enough screens to show all your dashboards, just set up some rotation and set a timing on it. Works really great in a NOC. So quick overview. Just think of VROPS as a place for that single pane of glass so that you can display more than what it's collecting from vCenter. The text display widgets, just think outside of the box. I really think they should rename that to the cool shit widget, because if you can display weather and websites that you create internally, it's really good widget. And then all the different ways that you can display the dashboards to users. It's whatever works best in your environment. So, I should go out and start creating your own single pane of glass. If you want to see what I'm working on next, just follow me on Twitter @DaleHassier, or go out and check out my blog site. It's vcrocs.info. So thanks for watching. I hope you learned something, and reach out to me afterwards if you have any additional questions. Thanks.
Welcome to the presentation on Cloud IQ, how to debug your VMware installations on the go with Dell EMC Cloud IQ. I'm Susan Sharp, Cloud IQ Product Manager. Cloud IQ provides you intelligent insights about your infrastructure, particularly by providing proactive monitoring and predictive analytics. One of the key advantages that we have with Cloud IQ is the human intelligence regarding the Cloud IQ ecosystem, leveraging the strength and power of the Dell technical community. That includes the developers and architects who are actually developing Cloud IQ, along with the product team developers who provide product-specific subject matter expertise. It also includes the support engineers who bring forward breadth and depth of vast subject matter expertise, knowing that special thing to look for or the things that you need to proactively be aware of, so that you can better understand your environment and take actions to address potential risks before they become real issues in your environment. And it also includes members of your Dell account team, whom you can invite to be trusted advisors so that they can also see the insights that Cloud IQ provides and help ensure you get the very best from your Dell infrastructure. We hired a third-party evaluator to compare Cloud IQ to some of the other products out in the marketplace. And they found that time and time again, Cloud IQ demonstrated an ability to allow users to reach faster time to insights. So hopefully you'll see that benefit too when you use Cloud IQ. When we talk about Cloud IQ, the three main pillars we talk about are reducing risk, planning ahead, and improving productivity. So I'll tell you a little more about each of those. We'll start with how Cloud IQ can help you reduce risk. One way that Cloud IQ can help you reduce risk is with the proactive health scores that you see here, where we provide a per system health score that will quickly identify systems that are at potential risk and also provide the recommended remediation to address that potential risk so that you can avoid real issues in your environment. We also have a unique performance impact analysis and anomaly detection capability that allows you troubleshooting all the way from the system level all the way down to the VM level. And this is where I will showcase this capability of Cloud IQ in the demonstration portion of this session. Along with this impact and anomaly detection, we'll also identify workloads that are in contention of the system or pool resources and need to be redistributed to remove that bottleneck. Cloud IQ also allows you to intelligently plan ahead. This was a key area where, with the ability that Cloud IQ provides for predicting capacity reaching full, we're able to provide an almost 10x advantage for our users. Cloud IQ provides both a short-term capacity full prediction as well as longer-term capacity forecasting, so that helps with both risk avoidance in terms of avoiding a data unavailability and also providing intelligence in your ongoing planning and forecasting tasks. We also recently added the ability to detect capacity anomalies. Think of this as a run-on-the-bank scenario and enabling you to avoid that 2 a.m. phone call when all of a sudden your capacity has reached full. Additionally, Cloud IQ enables you to improve productivity. One way of doing that is by the fact that Cloud IQ has a breadth of data center support. Cloud IQ supports the majority of all Dell storage assets as well as connector switches and is integrated with VMware. I'll give some details on that in the next slide. I also mentioned the trusted advisors. With all of us needing to do more with less, think of leveraging your trusted advisors for the additional expertise, additional proactive monitoring for your environment. Customers can simply invite members of their Dell account team to be trusted advisors, and that will enable them to log into Cloud IQ as well as you to be able to look for potential issues or potential areas of risk that need addressing. And finally, because Cloud IQ is hosted in the Dell private, secure infrastructure, you get immediate time to value with Cloud IQ. Once you've set up your Dell storage assets and connected via remote telemetry, you can log in to cloudiq.emc.com and start viewing Cloud IQ and your assets. Cloud IQ integration with vSphere obviously starts with vSphere. And then we have a special Cloud IQ collector. Think of it as an aggregator of the key vSphere telemetry. That then gets sent to the Dell Secure Telemetry Gateway. So all of the left-hand side is on your premises. And then that Secure Telemetry Gateway then sends the telemetry into Cloud IQ for preliminary ingest and analytics. And then that information is displayed in the user interface, the browser or the mobile app. This Cloud IQ collector is available for download from the Cloud IQ application. So you can simply click to download the collector app. I'll show you when I shift over to the demo, and then you can simply set up that vApp and start collecting the data, the telemetry data from your vSphere instance. So with that, let's shift into the demonstration. So I talked about the user interface and the Cloud IQ mobile app. So let's talk about how you would use those with your vSphere and VMware infrastructure. So here's the mobile app. And on the mobile app, there's a special area here that will draw your attention to whether there's been performance impacts in your environment. So you can drill a little bit more in detail, and you can easily see right here from the mobile app that there are issues with block latency in terms of performance impacts as indicated by the pink shading, and also performance anomalies as indicated by the blue shading. So what this does is it gives you infrastructure insights right there in the palm of your hand with the mobile app. So logical next steps would be you would hop on over into the Cloud IQ web app. And so this is the Cloud IQ web app. You can see here, for instance, information about the Cloud IQ collectors, the system health, the capacity approaching full that I talked about. And as you keep scrolling down, you see an area indicating performance impacts. And one of the key points I want to make about this is both from that mobile app and here right on the overview page of Cloud IQ is going to make you aware of these performance impacts. So we want to avoid any more hunting for that needle in the haystack. We're going to bring it right up to the top and make it prominent so it's easy for you to know about, so that you can streamline your time to resolution. Let's look a little bit more at these analytics and how they work. So I've now drilled into the storage system. This happens to be a Unity XT. You can see the top talkers here at the top of this page. And as you scroll down, you see, again, just as you saw in the mobile app screenshot, you can see both performance impacts and performance anomalies. Performance anomalies are indicated where, based on the machine learning algorithm that CloudIQ employs using a seasonality algorithm, that's indicated by the gray, we can indicate for this individual system, for this time of day and day of week, there's been an observed anomaly. We're tracking that over a 3-week period, and so this is an anomaly that has occurred outside the normal range, again, for this time of day and day of week, outside what has been established as normal over those 3 weeks. In addition to that, we have partnered this with another algorithm, a time series algorithm, time series correlation, where we can correlate that at the same time as these spikes in latency, there's been a drop in kind of the inversely related system performance metrics, IOPS, and bandwidth. So with these two algorithms, the CloudIQ analytics engine can indicate for you, first of all, when there's been an observed performance anomaly, and second of all, when there's been an observed actual impact in the environment. So now we've told you that there is an impact, and so the next steps are what might be causing it. And so this is where the power of context is really important. Right here in the context of this system graph, you can click and drag to then identify what are the storage objects that may be contributing to this performance impact and anomaly. And so, for instance, if you look at this particular storage object, you can see the performance metric there looks awfully suspicious and awfully similar. And so this provides a very simple way to drill right here in the context of what you're looking at the system level to then present that information at the LUN level, the storage object level. Similar metrics now at the storage object level, latency, IOPS, and bandwidth. And as we saw at the system level, again, an anomaly now for this LUN at this time of day and day of week, as well as the same algorithm applied now at the LUN level that we talked about at the system level, where we have a time series correlation where the spike in latency is correlated with a drop in IOPS and bandwidth. So you may be saying, okay, well, that's great, all about storage, but I want to know about the VM. Of course you do. So that's the next thing that we show. So like we did earlier, you can click and drag over the area of interest on the graph. And now, as you saw before, we now go all the way down to the VM level. Again, in the context of that LUN, I can click and investigate further with the VM. Again, using that special CloudIQ collector I showed you about before, where you can download it right here from the CloudIQ application. Right here, you can download that collector vApp and then deploy it. Just some real simple instructions right there. All right, so back to this VM landing page. So you can see here the key performance indicators for the VM, the CPU readiness, the active memory, and then the storage latency. Now, in this particular troubleshooting flow, I started at the system level and worked my way down to the VM. But imagine if instead you had chosen to simply search for the name of that VM and arrived at this page. You can click anywhere on the latency graph, and we'll provide for you an end-to-end map that will identify all of the components along the way for that VM. And note that when I click in the pink area where the VM had a performance impact, it will likewise indicate the various storage objects, or storage entities along the way that likewise had a performance impact. So effectively connecting the dots for you to help you again understand that performance impact and help you find that needle in the haystack. All right, so we started at the system level. We worked our way down to the VM level. Again, noting you could have reversed that direction. But now the question is, what can be done to remove that bottleneck for the VM? And so in this case, I'm just going to back up a step. That was the LUN that we looked at. If I go back to the LUN page, this was the graph we were looking at a moment ago. You can then see additional details, this is where the workload contention analysis comes in. And Cloud IQ will indicate for you where there are other workloads contending for the same resources as the LUN with which that VM is associated. So this is a pretty strong recommendation that if you can distribute these workloads, perhaps to another pool for a Unity system or perhaps a whole nother storage system, then you would remove that bottleneck. You would allow that LUN to receive the resources that it needs, and therefore the VMs associated with that LUN. So hopefully you've seen that end-to-end, in context, unique capabilities that Cloud IQ provides for you to intelligently troubleshoot performance issues in your environment and gives you strong recommendation for how to remediate those performance bottlenecks so that you can remove them. Returning to our presentation, I talked about immediate time to value. All you have to do is install and configure your Dell EMC devices, connect that remote telemetry, including the Cloud IQ collector that will bring information from vSphere into the secure remote gateway, and then simply log in and use Cloud IQ. Log in to cloudiq.dellemc.com and start using it. You'll log in with your pro support credentials. And I haven't mentioned it yet, but maybe one of the best things about Cloud IQ is all of this at no additional cost. We view Cloud IQ as an enabler so that you can unlock the power of your Dell EMC devices. So again, log in to cloudiq.dellemc.com and start using it today. To summarize, Cloud IQ provides intelligent infrastructure insights by reducing risk, identifying and avoiding issues to expedite troubleshooting, enabling you to intelligently plan ahead by anticipating business needs and avoiding outages, and by allowing you to improve productivity with a single pane of glass across your data center, including your Dell storage assets and VMware. So get started today and start getting advantage with the faster time to insights. Thank you for listening.
Hello, everybody. Thank you for joining for this session today. Today, I'm going to talk about VxRail in the real world. I will share some experience that I have with this kind of appliance. And I will share with you some tips and tricks, okay? Well, I'll talk a little about me. My name is Arla Santana. I am a Brazilian. And so I have more than 20 years in experience with IT infrastructure, especially with VxRail. I'm started with 400 of VxRail. It's an EvoRail, okay? And if you want to learn more about me, access my LinkedIn. Have an entire description there, and can you contact me through LinkedIn, okay? And then I will start our agenda for today. The first part of our presentation, we are talking a little about key points of VxRail, and after we are describe some important steps or key points or some tips about the installation, and after install, we have some key points to pay attention, and some tips and some problems I faced during the updating the device, and I will share some tips with you, and and some reference and docs to solve possible problems during the updating or during using the device and day by day during the day by day. Okay, so the key points of VxRail. In my opinion, VxRail is a game changer. For me, is the best HCI solution. I have some experience with other players, other solutions, but for me, if you use VMware, if you have this free infrastructure, VxRail is the best solution, because the true single pane of glass, you can do everything on the same screen, the vCenter screen, and this is great. because other solutions, maybe you need to go out of the center, perform some tasks, return to the center. In this case, it's not. This is truly real single panel of glass. You do everything inside the center. The interface you are very well customized using on your day-by-day IT administration, IT infrastructure administration. And the other interesting fact is the compatibility, fully compatible with vSAN. Some years ago, during VMworld, I do not remember the exact year, I watched a presentation about problems with vSAN. And one of the most common problems with vSAN is about compatibility. And other thing is very interesting about VxRail is the real on-click update. You press on button and everything goes automatically. You know, do you have firmware updates? Do you have vSphere updates? Do you have vCenter updates? Don't worry about these, and the process is very automated, and you don't need to take care. You don't need to worry about this. You don't worry about, okay? And the other interesting fact is the unique point of contact. If you have problem, you just call for one person, one number, and they will solve your problem without need to contact many vendors. This is a great advantage of the HCI, and especially when you're working with a VxRail. Well, now I will share some tips about the installation. The first one is don't ignore the requirements, especially about network and DNS. You need to spend some time planning your installation, and it's very, very important using the solve procedures for install. I have experience with more 200 devices deployed, and every installation is a new installation, and every installation do you face different kinds of problems, and many times the problems are occurring because sometimes you're not check and trying the requirements, especially about the network. Okay, and it's not a problem if you spend some time planning your installation, reviewing requirements. Okay, and if you are using Dell network switch, smart fabric switch, do you not need to configure the switch? Many people said, no, this is not so good. But if you deploying a cluster with a lot of nodes, maybe this is a good idea. Well, it's preferred to use the switch in the mode, not in the stacking mode. Prefer to use VLT if you are using Dell networking, or VPC if you are using Cisco switches, or other manufacturers have different names for the same feature. I don't recommend the use of stacking, because when you use Tor switch in the stacking mode, when you need to perform some kind of maintenance like firmware updates, you can incurring on network disrupt and network down, and this is not good. And when you're planning your network for HCI solution, especially about VxRail, we were recommending for this. The other switches see like one switch, okay? But do you have benefits about this configuration? Because you can perform updates without any network voltage, okay? VxRail requires some specific VLANs, and you need to configure that before you start your implementation. When you So after you put the device on the rack, you need to cable them. When you are cable them, pay attention in the ports. Don't worry about network interface cards outside the onboard interface cards, because the setup using only onboard cards, okay? VXRail planning guide, this document you can find during the LMC websites. At the end of the presentation, I will share the address of the LMC websites when you where you want to find this kind of documentation. After installing the devices, after cable the device, I recommend to configure all iDirect of all nodes first, because sometimes I face problems. I had problems with some implementations. I remember a specific case. I spent a lot of hours believing that the problem is network configuration. And in fact, the problem was a problem. You need to look at direct console user interface of each node and look if the information about PSNT is present. Some nodes produced last year have a bug with this, and they don't have PSNT identification, and these not iDirect first. Look if each nodes are health. Look for hardware problems before you start your implementation, in fact. In case of using external vCenter, take a look at VXRail vCenter Server Planning Guide. This is a document because when you use external vCenter Server, you need to check not only the Center Server Planning Guide, but support matrix. You need to check if you have the full IP address, but I really recommend you to change for a definitive IP address before you start your cluster building, okay? And for 2-node cluster, I really recommend you to configure a witness traffic separation, a special network, a separate VLAN for this, and take care with you the witness about 2 facts. The documentation about 2-node cluster is very simple, and sometimes you face a lot of the problems with 2-node clusters because it's not so common implementation. It's not well covered in the training for implementation of VXRail. If you perform VXRail implementation course, it's a small portion of the course that they talking about 2-node cluster, but 2-node cluster is a little difficult to put on production because the documentation are simple and not cover all aspects. My recommendation is for this is use the same version of the rules about the vSAN witness. When you download and deploy the vSAN witness, take care with this, because if the vSAN witness has a different disk version than the hosts, you can't perform the deploy of the VXRail 2-node cluster. Okay. Well, if it's happened during your installation, you face this screen, do not panic. I face this kind of the problem in some implementations. In the most of case, just press try again, and this solves the problem. Many times this is occurring because some tasks do not perform at the correct time, and because of these, you face this kind of the problem during the implementation. But just press try again. If this doesn't work, look at the log and try to do the task manually. Example, in one of my implementations, I faced a problem. with a specific step when the configuring enhanced vMotion compatibility and the installation stop. I faced similar screen of this, but I just read logs and enable ransom center compatibility manually and done problem and the installation, and I press try again and the install continue and the cluster was deployed with success. After install, it's very important to rename entities because the X-Rail after the installation has a different names. It's not different, strange names. Not to say strange is the best word for this, but many customers, many people want to rename the entities. But my recommendation is look for the solved procedures for this, because not any entity can be renamed. Okay, and the solved procedures are very, very complete about this. They have step-by-step instructions to perform renaming entities. Okay, enable vSun performance services is very important too. Enable Skyline, the online health check. I recommend this because before you enter in production, the environment start production. This is very important. You make a health check of your cluster using the online option. If you want to use the duplication, compression, and encryption, this is the time before you put the device in production. Because when you activate, when you enable these features, it's necessary to reformat the disks. And this task is time-consuming. And the other thing, during this task executing, you have limited availability. Because of this, I recommend, and after install, before you move your workloads to the new cluster, enable this. Okay. And the other very important step is enable ESRS, the call home function of the X-Rail. And this is not only used for problems. Recently, we have ACA as an analytical consulting engine. The data transferred by ESRS are used for analytical consulting engine. Analytical consulting engine is a very new feature introduced last December. And it's very, very interesting because this feature provides information, analytical information about your cluster and perform updates. When you perform updates, I prefer, for my experience with a lot of implementations, to use offline bundle and the internet upgrades, especially when you are deploying more than one cluster in the same organization. Maybe this is a strange scenario, but it's not so strange for me because we have a limit on the standard cluster of 64 nodes, and sometimes some companies work with 2 or 3 clusters, and sometimes when you need to deploy more than one cluster, you need to do that. Download the offline bundle and perform updates faster than you use the internet upgrade. Okay. If you found errors during the upgrade, don't worry. Again, don't worry. Just press try again. It's most cases enough. Okay. And I performed installation here in Brazil and in a customer, a lot of 2-node clusters in remote regions of Brazil. And some regions don't have good power sources. And sometimes during the update, I face a power outage. Okay, don't worry if it is occurred because you just power on the solution again, and the update continue. Okay, very rarely you face a problem that you need to contact support to solve this kind of problem. And if you face some error during the upgrade, please look the log. Sometimes the log have more information, more detailed information that help you to solve the problem. Well, solve the problems. Before you can contact the support, okay. Before you contact support, take a look at event code reference. And this, I put some reference here, just 2 links, because this documentation changes every day. And just put two links. The Solve online. The Solve has a lot of procedures step by step. And the InfoRub. InfoRub is an entire documentation about VxRail. So for today is this. Thank you for your time. And you have doubts, feel free to contact me. Okay, thank you.
Hi, this is Milind Halpet, Global Cloud Practice Vice President with vTechTalks. And today we are going to talk about how do we provide a consistent experience from cloud to edge with boundaryless data protection solutions. Next slide, please. So when we look at the cloud trends, the reality today is, the cloud spends are going to go from 260 billion per year to almost 927 billion per year. At the same time, we see enterprises embarking on the digital transformation journey, and the adoption of cloud across enterprises are accelerating. And this actually points to one outcome. The volume of data that is getting generated in the enterprises are skyrocketing, whether we look at data that is structured or unstructured. And at the same time, organizations are going through certain challenges. IT needs to do more with less resources. And at the same time, data protection is at the center of the entire transformation. Anything with respect to the data protection issues that may lead to revenue loss, it may lead to brand problems. So it is actually a critical problem for any enterprise to solve. And when we look at some of the common investment priorities, in fact, data protection is the number one priority across the enterprises. Enterprise needs to manage the data lifecycle management all the way from the backup, retention, disaster recovery, archival, and long-time retentions. So with this backdrop, I would like to move to the next slide where we'll deep dive a little bit into the solutions. Just a little bit of background about our partnership. Wipro, Dell, and VMware have a solid partnership going on for decades. With a very rich system integration, transformation, and managed services experience, Wipro has been innovating in the market along with the Dell to release the cutting-edge solutions to the market, along with VMware as well. These solutions actually span across data center to cloud to edge and to the end-user devices. And some of the most important considerations while we talk about the solution sets is, do our solutions offer lower cost and high value? Does that actually integrate with the other ecosystems within the enterprise? How automation becomes an important tenet of the solution? And finally, these solutions have to work seamlessly. So are our solutions service assured? And are they trusted solutions backed by VMware as well as Dell? So with this, let's go to the next slide. So to solve these kinds of problems within the enterprise, we have a platform, what we call as the boundaryless enterprise, or the BLE. There are multiple components within the BLE. It has a hybrid IT fabric. It has got the engine to manage the modern application development using the Kubernetes ecosystem as well as the VMware Tanzu. But the most important thing which is relevant for today's conversation here is the component what we call as the boundaryless data protection, or BLDP. And in the next set of slides, we'll go a little bit deep dive into BLDP, and we'll talk about the utility and how the reference architecture yields organizations to protect their data, irrespective of whether it is an on-prem or a private cloud or a multi-cloud across various deployment models. Next slide, please. So in this slide, as you see here, there are plethoras of technologies that comes together to solve this problem. And that is why we are saying data protection has to go without confinement of boundaries. The reality today, the world is hybrid. Enterprises already have moved from on-prem to cloud. There is virtualized infrastructure, there's legacy infrastructure. There are newer patterns, for example, converged infrastructure, hyper-converged. And then when we look at deployment options, we have IaaS, infrastructure as a service, we have PaaS, we have some applications which are running across SaaS as well. And on an average, when we look at the RPO and RTO requirements, enterprises need a 4-hour RPO and RTO, and some of the business critical applications, they need instant recoveries. So how do we provide all the services all the way from replication to snapshots, backup and archival, and this has to be blended into the entire data management strategy, and protection needs to be looked upon in a holistic fashion. From an application perspective, we know that applications are now moving away from the traditional monolithic applications into digital applications. Then there are COTS applications within the enterprises. And these applications are spread across, integrated infrastructures, converged. Most of the applications are now running on software defined using infrastructure as a code. And from a consumption perspective, the models are getting transformed into as a service construct. So the data protection strategy comes in the center of all this evolution. On the application side, while there is a transformation that is already underway, on the infrastructure side, yes, the reality is multi-clouds. How do we protect data across all these clouds in a holistic fashion without compromising integrity is the important part of the solution. With this, we'll move to the next slide, please. So the key part to understand here is how do we provide a single pane of glass management to solve this problem? How can we manage, protect, and recover enterprise-wide data, whether it is AWS, Azure, or Google Clouds, or any other public cloud, or it could be on-prem private cloud as well. And at the same time, when we look at some of the multi-cloud use cases, as I said, the business requirements are very stringent today. The business critical applications need immediate backup and recovery options. At the same time, organizations are trying to cut the cost by using cloud as a backup option, long-term retention options. So these use cases will have to come together, and a single pane of glass is important to orchestrate these use cases in a seamless fashion. And when we talk about these solutions, the solution has to be scalable. It has to have a high level of cloud performance. And at the same time, it has to protect all kinds of workloads. And this is where we are talking about the Power Protect solution as an umbrella technology platform that is innovated from Dell as well as with VMware. And Wipro System Integration Services brings this life as organizations embark on protecting data across multiple clouds. Now we are actually partnering very closely to take this Power Protect solutions to the market. With this, we'll go to the next slide, please. So the most important part of this Power Protect umbrella platform is it is enterprise-grade data protection. What it means is it provides classic features such as scheduling, service cataloging, policies, governance, automation, compliance, and most of the organizations today have very stringent SLAs. So when we talk about enterprise-grade policies, this platform, Power Protect, along with the services overlaid from Wipro, provides this enterprise-grade data protection services. At the same time, we know that organizations are embarking on a new journey where they are innovating on the digital applications using Kubernetes, VMware, Tanzu, and some of these related technologies. So the good part of this entire solution is it works for the digital native application landscape as well. We can protect data that is coming out from the Kubernetes ecosystem. And at the same time, the cloud native architecture that we are talking here, it supports the entire Kubernetes community. So the key message here is we can actually look at backing up the Kubernetes clusters and the persistent volumes. That is the part for the digital workloads data protection. At the same time, it manages the traditional data protection, the ones which are running in IaaS data protection. So basically, it brings all kinds of data lifecycle management across clouds, across deployment models, and heterogeneous applications into a single pane of glass. And that is the power of the partnership that we are talking here. With this, I'll move to the next slide. What are the customer benefits? End of the day, when customers are embarking on the digital transformation journey, innovation is the key requirement. While organizations are trying to innovate and get into next generation business model, trying to create a competitive advantage and opening a new digital channel for the business, the time to market and time to innovate is of supreme importance. The second one, enterprises do not have a lot of funds available to drive this transformation. So always there is a push to reduce the run spend and champion the change fund. The third component here is architecture really matters. How can we simplify this architecture? The complexity that I talked about, multiple clouds, multiple deployment models, different application patterns, and data protection is one common denominator that has to connect all these models together and protect the data. Make sure that replication, snapshotting, the long-term retentions, the policies, everything works according to the enterprise standards. The last but not the least, compliance and making sure that we are creating a flexible consumption model, which is very transparent for enterprises. And the entire 4 pillars of this benefits has to be very simple. It has to be consistent operations, which can abstract the complexity while there is technology underpinnings below that. So these are the 5 things that comes together. So when we talk about providing consistent experience across clouds, across cloud to data center to edge, the boundaryless data protection is one of the key solution elements that enterprises need to embark on. Now, again, I would like to round off by mentioning the partnership between VMware, Dell, and Wipro has come together. The engineering teams have worked together to create a standard reference architecture. And there is a definite roadmap as well as the use cases that are stress tested to work in the enterprise scenarios. We are committed to drive enterprise transformation for our customers. And we look forward to seeing you in VMworld 2020 and stay tuned for the further updates. Thank you.
I'm Ian Breitner from the Storage Solutions team at Dell Technologies, and thanks for joining. Today, we're going to talk about edge computing and how that's going to impact application modernization plans. Now, everyone's heard of the 5 Ws. Perhaps they may be more familiar this way. We'll go through each of these in turn, and the order in which we may do them will make sense to me, perhaps not to you. So let's start with the what. What exactly is edge computing? Edge computing is defined by processing data at or near the source of the data. It is essentially a distributed computing environment. Data volume is growing, and IDC estimates that in 5 years there will be about 79 zettabytes of data from roughly 42 billion devices. As the volume and velocity of data increases, so too does the inefficiency of streaming all this information to a cloud or data center for processing. Edge solutions are designed to complement data center and cloud services. Edge computing serves as the decentralized extension of the campus network or cellular networks or data center networks or even the cloud. Santosh Rao from Gartner says, organizations that have embarked on a digital business journey have realized that a more decentralized approach is required to address digital business infrastructure requirements. So here's a simpler architectural view. Both cloud and data center have a part to play, but we now have a need to service new devices by delivering compute power close to the device itself. And those devices are proliferating at a great rate. And spoiler alert, it's not just compute power that's needed. but networking and storage as well. So why? We've defined edge as bringing compute in proximity to the source of the data. Edge computing is designed to complement existing public cloud, data center, or co-location deployments, and edge data centers offer advantages that none of these possess. It's due to the compute proximity to the data that is the core strength of edge computing. Its ability to support applications that demand a significant amount of bandwidth, require rapid response times, are latency sensitive, or any combination of them. And network traffic performance is much less of an issue at an edge location than with a data center or co-location deployment, or even the public cloud. In these latter cases, data needs to be moved from the location where it is acquired to a central location for processing. Doing so incurs latency. We still have not been able to communicate significantly faster than the speed of light. But across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partner. And this is kind of interesting. The movement to edge computing parallels the cyclical nature of IT trends. What began with centralized mainframes eventually moved to a decentralized approach with client-server networks. Then the meteoric rise of the public cloud shifted computing back towards a centralized approach. Only to have the recent rise in popularity of hybrid cloud deployments move the needle back towards a decentralized model. So when is this need for edge computing going to occur? The news, good or bad, is that it is occurring now. In fact, it started back in 2009 when Carnegie Mellon University used the term cloudlet to describe a micro data center, basically an edge data center. However, it was not until 2016 when edge deployments really started. Gartner estimated that only 10% of data was processed outside of the data center and cloud back in 2015. But now they estimate that within 5 years, the amount of data processed outside of a traditional data center or cloud will be 75%. This growth is basically due to IoT devices. These include mobile devices that we all use daily, like cell phones and GPS location services and so on. And they include new data sources, IoT devices that are being deployed in a variety of locations: vehicles, personal healthcare, hospitals and clinics, smart cities, retail locations, aircraft, ships, manufacturing, and so on. Growth rates for edge computing are estimated by analysts to be from 11% to 12% compound annual growth rate. And this might well be a conservative estimate. Those smart thermostats, smart utility meters, ever-growing mobile devices with specialized apps are only adding to the data that is being generated. You can see from this chart that the growth of the edge is growing exponentially, and we are here in 2020. So the Who. No, not the band. Who is looking to use edge computing? The number of use cases is still increasing, but common ones include supporting advanced Internet of Things appliances and augmented reality applications. So, for example, retailers can leverage AR to improve customer experiences by creating apps that help customers find their way around shops, implement network smart mirrors to try on clothes without a changing room, or run personalized promotions and offers that leverage the consumer's historical purchases and personal tastes. Within manufacturing environments, artificial intelligence can be used for predictive maintenance of expensive machinery, drive down long-term maintenance costs, and significantly reduce the risk of failure. Elsewhere, raw input from IoT sensors can be leveraged for quality control or to reduce wastage. Edge computing solutions can take many forms. They can be mobile in a vehicle or smartphone. They can be static, that is part of a building management solution, manufacturing plant, or an offshore oil rig. Or they can be a combination, such as in hospitals or other medical settings. A wearable health monitor is an example of a basic edge solution. It can locally analyze data like heart rate or sleep patterns and provide recommendations without a frequent need to connect back to a main data center or cloud. The capabilities of edge computing solutions range from basic event filtering to complex event processing. By 2024, edge data centers are projected to exceed edge data centers are projected to exceed $13 billion, with the IT and telecom sectors driving growth. Manufacturers in the edge data center market are providing several effective solutions that allow businesses to adopt edge computing technologies for managing their enterprise data. For instance, Dell Technologies, my employer, is several computing solutions such as PowerEdge, XR2, R740, and R740XD servers that are optimized for mobile virtual network functions. But they also have a new offering, PowerStore, a storage array that not only can scale up and scale out, but can also run virtualized applications on the array itself. PowerStore natively runs ESXi. The management of the storage is handled in a VM, and the array can run user VMs. It appears in a vCenter as another VMware host and acts as with any vSphere host. It is highly redundant with dual controllers, servers if you like, which act cooperatively in managing the storage. The value this brings to edge computing is significant. Not only can PowerStore be used to house the data collected at the edge, it can also run applications that can process that data. And it does this in a very small 2RU form factor, about 3.5 inches high. And if this is of interest, I would encourage you to join Marco Abella's VMworld session on PowerStore or Heather Hitchcock's session on healthcare, where she talks about automating an ICU. So the where. Edge servers can form clusters or micro data centers where more computing power is needed locally. And they can be anywhere. And in fact, they are already everywhere. More complex edge computing solutions can act as gateways. In a vehicle, for example, an edge solution may aggregate local data from traffic signals, GPS devices, and other vehicles, proximity sensors, and so on, and process this information locally to improve safety or navigation. More complex still are edge servers, such as those that are currently being deployed in the next generation, that is 5G mobile communication networks. And these will host applications and cache content for local subscribers. So from connected vehicles to intelligent bots on the factory floor, the amount of data from devices being generated in our world is higher than ever before. Yet most of this IoT data is not exploited or used at all. For example, a McKinsey & Company study a few years back found that an offshore oil rig generates data from 30,000 sensors, but less than 1% of that data is currently used to make decisions. The edge is a focus area of burgeoning distributed computing framework, which is being created due to the latency and bandwidth requirements for new use cases. According to IDC's 2019 Data Center Operational Survey, 79% of United States-based organizations were planning to deploy more IT services at edge locations. Supporting new digital services at scale across many locations requires the ability to deploy and maintain infrastructure and enable connectivity in many locations. Organizations will be challenged to support connectivity needed for physical and data security in these locations. And real estate will play an increasingly role in edge deployments. For example, Walmart is exploring ways to rent out edge computing, leveraging its retail footprint. Retailers have the locations to enable edge computing. And there are several risks inherent in edge computing. So across all industries, the digital transformation of products and processes is creating new ways to connect with the customer and partners. Much of this innovation depends upon having IT service in new locations, that is, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of these investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail location or a remote site. It means the ability to overcome the variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms organizations. Evaluating, deploying, and operating Yes, I can. Already. So there are risks associated with edge computing. Across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partners. Much of this innovation depends upon having IT service in new locations, that is to say, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of those investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail or remote site. It means the ability to overcome variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms will strain the capabilities of even the most advanced IT organizations. Small problems will become magnified as the scaling increases exponentially. The impact could result in service interruption at best, or security breach at worst. As with all rapidly evolving technologies, evaluating, deploying, and operating edge computing solutions has its risks, and they come in many forms, but a key one relates to security. Extending your footprint using edge computing exponentially increases the surface area for attacks. Unsecure endpoints are already used in distributed denial of service attacks or as entry points to core networks. And another concern is that the cost of deploying and managing an edge computing environment can easily exceed the project's financial benefits. Moreover, projects can become victims of their own success. Scalability can become a serious issue as new IoT endpoints proliferate. And of course, there are additional challenges. Network resiliency. While within the edge location this is not an issue, there is still the need to move data sets back to the core, either for additional processing or for archival. Then there's scaling the number of edge locations can be challenging, as noted earlier. Bandwidth and spectrum constraints, and we expect that 5G will alleviate some of these. Another good one is data sovereignty and its application in the EU to collect the data. And this may well extend to other countries, such as Canada and the US. Also, procurement is shifting from CapEx-centric to OpEx-centric. Organizations may not want to own the infrastructure they use, but rather rent it. And then system complexity, as the edge expands, it becomes more and more complex, and there are more complex interactions required. Remember this diagram? This only has 50 devices in it. What happens when you end up with tens of thousands? And not to forget the shortage of skilled labor resources. Organizations are struggling with their cloud initiatives, and edge adds the need for a different skill set, which are even harder to find. Edge computing does help you unlock the potential of the vast untapped data that's created by connected devices. You can uncover new business opportunities, increase operational efficiency, and provide faster, more reliable and consistent experiences for your customers. The best edge computing models can help you accelerate performance by analyzing data locally. A well-considered approach to edge computing can keep workloads up to date according to predefined policies and can help maintain privacy, and will also help adhere to data residency laws and regulations. Developing a successful edge strategy requires taking into consideration the complexity of management endpoints and recognizing that scale and variability is dramatically different from traditional on-premises or public cloud deployments. And with that, I end my talk, and thank you for listening.
Welcome to the session today. We're going to talk about VM performance innovations around protecting your mission-critical applications. My name is Brian Reynolds, and I'm a product manager in the data protection division at Dell Technologies. We're going to talk a little bit about the challenges we have today when protecting our mission-critical applications and the innovations that we're working on in Dell and going to be previewing around the enhancements to our scale and performance when it comes to VM image backups. And finally, we'll talk a little bit about how this new enhanced data image backup is going to allow you to do more with your data than just protect it. So let's talk a little bit about the challenges. Today's VMs are faster and bigger. VMware continues to enhance the performance and capacity of the VM disks, which means that our VMs are running faster and they can handle more transactions. We're also seeing that they need to be able to accommodate that global environment, so they have fewer downtimes when we can be able to take those VM image backups. And when we talk about traditional backups, one of the challenges we have is when determining those deltas that we need to for being able to archive the data, we find that we have to halt the VM while we're looking and capturing that image. And that's going to result in the application becoming stunned. And the other problem we have is that we have a dependency on our external proxy, our agents. These agents we use to move and transfer the data to our storage. And these external proxies exist in our production environment, which means we have to be able to deploy and manage those resources, and they're taking away from our ability to support our production VMs. So let's look a little bit more into a VM image backup. There's really 3 stages that make up a backup. We have our snapshot creation, and this is where our point-in-time representation is collected for the VM and we use this to be able to determine the deltas. We see that this operation requires for us to be able to quiet that VM so that we can be able to get those changes. The next part of the process is to process those snapshots. And this is where we have to work with our external agents to move the data over and to determine what those changes and deltas are, and then send those over to storage. And finally, we have to clean up, which means that we need to consolidate that point-in-time representation with the current VM and ensure that we have all those changes captured. We tend to see a lot of IOPS degradation in both the creation and the deletion steps. We also see a lot of impact on our performance when it comes to processing and moving that data, since I'm using production resources. So that introduces the problem. How are customers getting around it? Well, today, they're using workarounds to solve or to deal with those issues. One of the things that they're doing is they're taking a limited set of data and trying to protect only that, which requires our users and customers to be able to determine what is the valuable data and continually making sure that they're protecting the right information. This still has a challenge because I still require my agents on the host now to be able to capture those file and application level data. The other option that we've seen customers try to do is limit the backups, not take as many, and be less frequent, and hoping to capture those backups during those downtimes. But in our global environment, we're finding that time is unpredictable, and I may need to have my systems up when a backup is scheduled. The other problem I have is that it increases the gap between my backups, which gives me fewer copies to be able to use for restore. And I have less ability to be flexible when it comes to restoring my system. So here at Dell, we've been working to enhance the way that we do VM image backups. And the way that we've been looking to solve this is to ensure that we eliminate the need to pause that VM during a backup. This solution that we're looking at is storage agnostic. So we're going to be able to leverage this across all our various storage platforms. And we're eliminating as well the need for us to be able to have that dependency on our external agents during that processing of the data and moving it to our storage. This would be ideal to solve those problems with your large data sets where you can't afford to have that IOP reduction. So let's talk a little bit about this new enhanced VM image protection. So first off, we've enabled our VMs to monitor the changes. And as PowerProtect Data Manager makes a request for a backup, it's able to get a transparent snapshot of those changes without any IOPS interference. And these snapshot then is able to be pushed directly from the ESX to our PowerProtect DD without having to do any additional hops. And then my final step is just cleaning up. And that cleanup operation is very simple. It's just a simple removal of that transparent snapshot with no requirement for me to sync up those changes with the current running VMDK. So this really allows us to be able to see improvements when it comes to performance. We've eliminated the need to create that point in time snapshot, which means that I no longer have that pause of my IOPS. And as we look at large VMs, I can be able to take that snapshot without any disruption to the business. And therefore, it is truly transparent. We've also been able to reduce the need for that cleanup. So therefore, the cleaning up and removal of that snapshot is a simple operation with no impact to that running VM. And in our labs, we see that those IOPS can stay consistent across the entire snapshot operation, which is ideal for those VMs which are large that need to be able to have their IOPS maintained in order to handle the high transactions that they're trying to process. From a scale perspective, we've removed the need to copy those changes to an external agent. And this has allowed us to be able to remove those hops. And so I no longer need to be concerned about where my external agents are deployed and how they're deployed and where they sit in relationship to my ESX. I've also been able to, with the embedded data mover, reduce the impact on our production environment. So we're no longer using production resources when we copy our data over from the ESX to the PowerProtect DD. And this has eliminated the need for a management of all of those external agents. Since I no longer have to deploy them, I no longer have to manage them and make sure that they're upgraded and that they're all running and keeping healthy. I no longer have that ownership, and I'm not leveraging my production resources to be able to have to allocate space for them. So therefore, I'm able to truly use my entire ESX for my production without having to account for space and resources required for data protection. I've also been able to ensure that as part of when we deploy that embedded data mover, we have the ability for it to be propagated and scaled automatically. So as you add hosts to your cluster, that data mover will get automatically moved and installed and deployed and configured. So there's no work for you as a customer to ensure that that data mover is up and running. And as we expand our environments, those data movers will expand with it. So this is really changing the way that we can protect those VMs. So the VMs that used to be unprotectable, we will now be able to protect, which allows you to be able to take more backups and no longer have to wait for downtime, which gives you a lot more flexibility when it comes to providing solid recovery. Since your copies will be more frequent, you're not going to have data being lost. And I'll have the ability to recover those in the same manner that I do with a backup. I'll be able to go directly from the PowerProtect DD to the ESX with no additional hop or involvement of those external agents. And this ultimately allows us to focus back on the VM as a valuable asset. I no longer have to be concerned about what's on my VMs. I can protect the whole VM and be assured that I'm not losing any critical data. Nor do I have to be working with trying to manage all of those agents that may be looking for the file data or application data. I can just protect the whole VM, no agents needed. So that really reduces the amount of infrastructure that I need to deploy and manage. It makes things easier for you as a customer to be able to ensure that you've got data protection up and running without requiring you to configure and manage in your production environment any of those external agents or those host agents. So in summary, this is going to be an opportunity. We're excited to present to you this new innovative way of doing enhanced VM image backups. We realize that this is going to provide you with a solution for those mission critical applications that today you cannot protect. And it'll give you complete coverage of your entire VM without having you to have to figure out what data needs to be protected or what's critical on that particular disk. And this is ideal when I need to be able to protect those VMs that have a need to be able to run in this global environment. And we're excited to offer this new enhanced VM image backup with the snapshot and the data movers that have been developed here at Dell Technologies. And this is going to open the door for you to be able to move over some of your systems that may be currently still physical to a virtualized environment and still be protected and have the same level of data protection that you would expect without the need of having to deploy all of those agents. And we're really excited to be able to provide this for you because we know this is a problem that's been around and we believe it's about time for it to be solved. So if you'd like to learn more about PowerProtect Data Manager and what we're doing to be able to enhance our data protection from a VM image perspective, please check out our website or join us on Twitter. And thank you very much for joining me in this session.
Hello, everybody. My name is Darren Schmitz, and today I'm going to be here to talk to you about VMware Cloud Foundation and deployments that involve your existing investments. So again, my name is Darren Schmitz. I'm a senior principal engineer from Dell Technologies. And so here we go. Today on the agenda, I'm going to give a brief VMware Cloud Foundation overview, talk a little bit about the benefits of using external storage with VCF, dive a little bit into VCF and vSphere with Tanzu, and last but not least, I have a live video demonstration of deploying a workload domain using the new iSCSI vVol storage in VCF 4.1. So with that, let's get going. So for VMware Cloud Foundation, if you're not familiar with the product, there are a lot of there's a couple major use cases for it. So the primary use case for deploying VCF is private and hybrid cloud. So in my opinion, one of the greatest things about VCF is it's basically the on-prem version of VMware Cloud on AWS. So you can provision your infrastructure, stand up your legacy apps, and then using the NSX networking, basically make a bridge between the on-prem and the cloud for hybrid cloud. The second primary use case for VMware Cloud Foundation is modernizing applications. So either you're developing a new application, a containerized application, or you're converting an existing legacy application into a more container-based architecture. Cloud Foundation is great for that. And last but not least, one of the other use cases for VCF is automating a Horizon VDI deployment. And by that, you can download a couple of modules, and it basically wizardizes, if that's a word, the deployment of a Horizon into VCF. When we look at VMware Cloud Foundation, there is the bill of materials is basically the listing of all of the software that kind of brings up, it's what makes up the SDDC, or the software defined data center. So at the top of the list, you're going to see SDDC Manager. And when you first have a VCF deployment, what you do is you deploy a OVA, a virtual machine called Cloud Builder, and you feed it some parameters, and it goes off and it deploys vSphere, vSAN, NSX, and vRealize Suite Lifecycle Management. So, and then last but not least, it deploys a virtual machine called the SDDC Manager machine to look over everything. So that's the main software components of VMware Cloud Foundation. In addition, there's a couple of add-on components, most of them in the vRealize suite of products, also Workspace ONE access. Those are all things that you can additionally add in if you need. So let's start looking at the hardware, physical hardware overview, because a lot of people are curious, what does this look like if it's sitting in my data center? So when we look at Dell EMC storage, and helping the portfolio, really with VCF, you start with a minimum of 4 nodes. And this can be expanded to a rack, a full rack, many racks. You add some top of rack switches, maybe even a management switch. The key is that you're adding a bunch of compute and basically servers that don't all have to be the same. You can have high-powered servers, medium-powered servers, and whatnot, and throw them in a rack and start creating what they call workload domains. But in any case, the first 4 servers that you deploy for VCF have to be the management domain, and that's a minimum of 4 servers, but depending upon how big you're going to scale, it can scale up to the vSphere configuration maximums. So, like I said, if you were to grab a bunch of hosts, any number of hosts, again, this conforms to the vSphere maximums, you can create what's called a workload domain. 1, 2, 3 workload domains, racks full of workload domains if you want. Now, some of the key things that I'm talking about today is really the add-on of Dell EMC storage, or any storage in general, to a workload domain. So in my lab, obviously, since I work at Dell Technologies, I have a bunch of Dell EMC PowerStore and Unity arrays, or you can create a workload domain with PowerMax, Platinum Storage, depending upon the workload. So that's part of what I really want to drill home today is that you don't have to, the deployment with VCF is super flexible, especially with VCF 4.1. So let's look at some of the storage options. So as I said, the first 4 servers, the management domain, those have to use vSAN. The vCenters, everything that gets rolled onto that is it's mandated that the management domain is backed by vSAN. However, the workload domains that I was just talking about, they can either use vSAN or external storage. And when we talk about external storage, there are 2 terms that I want to introduce to you if you haven't heard them before: principal and secondary storage. And by no means does principal mean a class of service with the storage. It's not that the principal is like the tier 1 storage and the secondary is the tier 2 storage. No, when I say principal and secondary, all I'm referring to is the order in which it's deployed. We call the first data store that's deployed the principal storage, and any data store that's once the workload domain is up and running, any data store you add after that is secondary storage. So again, the principal and secondary does not denote the class of storage. It's simply when it's deployed. So for those principal storage options, like I said, new to VCF 4.1 is the vVols, and that's supported by iSCSI, Fiber Channel, or NFS. But for principal, you can use vSAN, obviously, NFS v3, or what they call VMFS on Fiber Channel. Now, supplemental storage options, the 2 options that you just simply can't use to deploy a workload domain is just NFS v4 and VMFS on iSCSI. The rest of everything is available for supplemental storage options as well. So from the customer point of view, one of the key, in my opinion, some of the benefits of external storage is obviously with VCF is leveraging your existing storage array investments, right? So if you have an array in the environment that's maybe underutilized, has extra performance that you don't really want to, go by the wayside, obviously you can use this for storage in a VCF environment. Storage array is an important and sometimes expensive investment, and it's best, some customers like to leverage that. And so the second benefit, I think, with VCF and external storage arrays is that you can scale storage independently of the workload domain compute. And that's important because when you're using vSAN, you often have to scale the storage with the compute. And if you have a really compute low type workload and you have that requires just a ton of capacity, it's nice that you can attach a SAN to externally and scale that independently. The third benefit for using external storage is obviously if your business is dependent on some features that are embedded in the array that are are important to the business: replication, deduplication, metro cluster, stuff like that. So that is one additional reason for external storage arrays. But the final reason is just basically performance. So there are certain high demand workloads that just require external storage. So if the workload, if vSAN is not desired for a particular workload, then that's where maybe an external array can fill in and fill that gap. So let's talk about vSphere, vSphere with Tanzu on VCF. So in my opinion, one of the greatest things about Tanzu on VCF is that it is super easy to deploy. Basically, you create a workload domain, as you see on the right-hand side of the diagram. You basically create a workload domain. This deploys NSX. After that, you deploy an edge cluster. You enable workload management, and basically, it's up and running. You can run TKG on top of that, maybe load up Harbor, whatnot. But the greatest thing about this is that it is completely lifecycled by VCF. So it takes care of updating all the components when it's time to get to the next version of stuff. This is great, obviously, because as we are moving on to the next generation of apps, this allows people, obviously, to make new containerized applications or convert existing in-house applications to container-based. So if we bring this whole thing together, I think one of the greatest benefits of VCF, especially when you pair it with external storage, is that you can have your virtual machine workloads, which are maybe even your traditional virtual machine workloads, side by side with the cloud native applications, right? So this gives the administrators a one-stop shop, a single pane of glass to administrate everything and work on everything. And because of that obviously simplifies modernization initiatives. If there's applications that are being converted in the environment, all the better. So the cool thing about external storage, especially when we're talking about vVols being brought in as principal storage into VCF, is that these containerized applications that require the persistent storage can utilize any data store. So as you're adding supplemental storage or principal storage to the workload domain, all you need to do is add a tag to that data store, which tells the Tanzu, the Kubernetes, that is eligible for containerized persistent storage. So the great thing about that is that you can have different storage types underneath. Kubernetes doesn't care about it. And obviously with that, SPBM is utilized you can use that in the environment. If there's one thing I want to convey is that VCF with external storage just simply adds flexibility. You're really getting the best of both worlds. External storage and that flexibility really adds to the on-prem environment. And from there, that can be extended into the cloud or hybrid cloud, where you have certain apps out in maybe a VMware Cloud on AWS that talk back to the on-prem application. The great thing about this is that, as I said, flexibility, apps can live anywhere. So with that, I'm going to get to the live demonstration. So with VCF 4.1, we have the addition of vVols as principal storage. So in my lab, I'm going to show setting up an iSCSI workload domain that is backed by vVols. So the first thing I want to show you is in the network settings. When we create the network pool and give it a name, you're going to notice that the new thing in VCF 4.1 is a network type. They added a dedicated iSCSI networking type for iSCSI traffic with VCF. Now, previously they had NFS, but in 4.1 it adds iSCSI so that when you create that workload domain, it can basically create VM kernel interfaces for the iSCSI traffic. So you'll see we add these networks and we hit save, and that basically creates our network pool. From there, the next thing that we need to do is add our VASA provider. So to do that, there's a new section called Storage Settings. And as you can see, I have multiple different arrays in my lab, but I need to add my PowerStore array because that's one we're using for iSCSI today. So when we add the VASA provider, all we're doing is adding a name, the URL to the VASA provider, the username, password, matching up the container name, and the protocol. And then we can hit save. So again, multiple arrays in the environment, you can add multiple VASA providers. To set this up, previously, all we did on the ESX host is basically we went into the iSCSI and enabled it, cut and paste the IQN, and then added the dynamic target to the bottom. And basically that prepares the ESX host to talk to the array when the workload domain is rolled out. So on the array itself, the only thing that I had to do, this is my PowerStore array in my lab, is all I had to do is go in and add all the hosts. And as you can see, what I did is I simply added the host and pasted the IQN in there. If you'll notice, it's not active yet. There's no active sessions to it yet. It's just simply waiting for the connection when the workload domain gets rolled out. So when we flip back to the SDDC manager, the next thing we need to do is commission the hosts. So I click on that. Here's the checklist of all the things that need to be done to the hosts. As you can see, I already completed those. Now I'm going to import a JSON file to make this a little bit faster. I upload that, and then I can basically start the validation for commissioning the hosts. And I'm going to fast forward this so that we don't have to wait several minutes. This does take a minute or so for that to complete the validation. But once we do that, I can click on Next and Commission. So while this is commissioning the host, we can basically go out and look at the tasks. As you can see, it's running, and the commissioning takes about 2 minutes in my lab. And once the hosts are commissioned, they are all ready to go for creating a workload domain. So we flip over to our workload domains, say workload domain, VI workload domain. And here's where we choose for our principal storage type. And in this case, we're picking vVols because we're going to use iSCSI vVols. And we say begin. And I'm going to cut and paste basically all the information into this. But the information is just basically, names, cluster. The vCenter information is what I'm putting in now, and putting in the passwords for vCenter. Here's where we put in the networking information for NSXT. Again, we're putting the managers, the FQDNs for the managers in there. It automatically does the name resolution for the IP, and put in the passwords and say next. This next screen is where we specify the vVol storage that we want to use. So I'm using iSCSI, and that's going to allow me to select my PowerStore. And then we pick the storage container that I'd previously specified, the username I want to use, and then I can just paste in a data store name for that particular data store and say next. On the host selection screen, I basically am just picking the 4 hosts that I want added to this workload domain, and I say next. I select my licenses and say next. I review the object names for the switches and object types, and then I say finish. And this gets the workload domain deployment started. So if we drill down into the tasks, we've got to wait a second for the task to be populated, but in a second it will be there and we can click into it. As you can see, there's dozens of tasks that the workload domain needs to do, rolling out vCenter, rolling out NSX, deploying a bunch of stuff. I'm fast forwarding this, but in my lab it took about 49 minutes to deploy the workload domain. But when that's done, what I want to show you is that when we click on the workload domain, as you can see, it is listed as the storage is listed as vVol storage type. if we click into the domain and we open up vCenter, if we open up the vSphere client, this is going to bring us to our workload domain. It's a linked vCenter. So as you can see, my 4 hosts are in there. And to demonstrate vVol is working, I'm just going to basically create a brand new virtual machine just to create the vVols for this particular virtual machine. So type in a name for it. I select the cluster. I select the data store that particular virtual machine is going to be put on. I select the operating system, and I say next. Verify all of that information and click finish. And in a few seconds after that virtual machine is created, it's all done. And we can flip back over to the array to see it all in action. So if we click on storage and go into our storage container, you can see my VCF storage container that I specified earlier. If I flip over to the virtual volumes, you can see all of the demo VM virtual volumes and the cluster service vVols that the workload domain rolled out for that particular domain. So again, external storage is really beneficial when you add it in with VCF. As I said, there's tons of benefits, but the main benefit is adding flexibility to your deployment. So there are a couple of additional resources if you'd like to learn more. One of the documents that I maintain is the Validated Designs Dell EMC Storage with VMware Cloud Foundation. If you Google H17921 or click on the dell.com/storage resources and drill into the one of the PowerStore or Unity section, the document is in there. This guide is a step-by-step walkthrough on if you're a EMC customer or Dell storage customer. It really is a step-by-step guide on how to implement any of the storage arrays in the Dell EMC lineup as principal or supplemental storage in your environment. Obviously, the VMware Cloud Foundation link is out there for additional information about VMware Cloud Foundation. And with that, I want to thank you very much and have a good day.
Hello everyone. Today I'm going to be covering the considerations and constraints for running VMware Horizon on VMware Cloud on AWS. My name's Dean Lewis and I work as a technical account manager at VMware. You can contact me through my blog, theeducate.co.uk, and also on Twitter, SaintDLE. As there's going to be a lot of information we're going to go through in the next 15 minutes for this recording, you can grab all this by going to the short link theexpert.me/VMC-Horizon, and I'll show these links at the end again as well. Just a quick overview of the agenda. Essentially, we're going to be looking at what Horizon is, what's special about it when it runs on VMC, talk about those considerations and constraints throughout, and then finish off on a final summary as you'd expect. Okay, so first and foremost, I'd like to start with Horizon 7 running on top of VMware Cloud and AWS is not desktop as a service. For those of you who may not be familiar with the VMC offering, it is a VMware managed service. We run the underlying vSphere platform for you, and you consume it by bringing your own virtual machines to the mix. By running Horizon 7 or 8, also known as 2006, which has just been recently announced, as an IaaS model, it means you bring the platform or the virtual machines onto the VMC and you run it yourself. So this will be self-managed, you are the tenant. This is in contrast to our Horizon Cloud offering, which is available on IBM SoftLayer and in Azure as well, which is a managed service from the Horizon platform itself. If you are using the Horizon Cloud platform, you will bring your virtual machine images and you will ask to deploy those images into a pool, which can be used by your users, but you will not have to manage the Horizon platform itself. Today, we're only going to be talking about running the IaaS model of running the IaaS components on VMC itself. Just also want to make a quick note. In VMware Horizon, we also support the cloud pod architecture. The reason why this is important is typically a lot of customers looking at running Horizon in VMC today already run Horizon in their on-prem data centers. You can extend your Horizon environment by using cloud pod architecture into the environments running in VMC and running in your on-prem vSphere environments. That creates a flexible, highly available platform. You will have to keep the platforms in sync with one another from a version and control point of view. But other than that, it's the exact same kind of architecture and references you'd be looking for to running cloud architecture if you were keeping all of your environments the same on-prem, but maybe between different data centers. Okay, so I'd like to allude to what is the big difference from a usability point of view for Horizon once it's stood up and running with VMC. And the answer is not much. It's a small little tick box. When you connect your vCenter server to tell the Horizon environment where it can deploy its resources to the platform, you tick the little box that highlights its VMware Cloud and AWS as highlighted by the big red arrow. And this lets the Horizon environment know that there is a limited RBAC model in place as part of the VMC platform because it is a partly managed service by VMware. I'd also like to note that there are some feature support that you need to take into consideration as well. So for example, we don't support view composer linked clones in VMC. We don't support running security servers, which are the Windows-based Horizon servers used in your DMZ. It's preferred to use the Unified Access Gateway. And also there's no ability to use things like vVols, for example. This isn't applicable for VMware Cloud and AWS because we provide you a single vSAN workload data store. vRealize for Horizon monitoring. We don't actively support it. It can be granted on an individual basis. Speak to your Horizon SME that you're aligned to if you're looking into running a Horizon project. And then finally, the just-in-time services, the JMP servers, you can use them in the Horizon Cloud Console instead of running them yourself as well. But again, some of this information as we start to release and ramp up with the GA dates for Horizon 8 will once again change again. So for example, just going back to the lack of linked clones, if you were deploying the latest version of Horizon, we only support instant clones anyway, so it's not as much as a consideration going forward. On our cloud.vmware.com website, we do have a reference architecture that takes you through the minimal viable product to start building your Horizon services in VMC. So let's look at some of the typical considerations and constraints. So the first one is always about your underlying platform. Identity management is always going to be key. Proximity to your Active Directory. So if you don't run any VMC services today and you're looking at this being your first foray, you need to consider at least a read-only domain controller stretching from your private or on-prem data centers into VMC. And ensure that you configure sites and services correctly within Active Directory so that when users are authenticating to any services running in VMware Cloud and AWS, it authenticates against the local domain controller and doesn't go across your VPN or WAN links back to your on-prem data centers. File shares is always the biggest one because files access is your end user experience for most users when they log on. They want to run Word documents, PowerPoint presentations, images that they may have edited. So again, proximity of these file shares to the user's desktop running VMware Cloud AWS is key. For the user documents, consider using technology such as Microsoft Distributed File Services if you are stretching between your on-prem environment to VMC. We also support native services within Amazon that you can bring across into the VMC environment as well, in particular the Amazon FX for Windows File Server service. So this is where you would spin up a Windows server as an EC2 instance, add the Amazon FX technology on top of it, and then use it to host the file shares back into your SDVC. User profiles. I'm pretty sure for those of you that have been sysadmins for many years, user profiles have been the bane of your life as much as they have been for myself. Consider using technologies such as user profile management. So for VMware, that would be our Dynamic Environment Manager, previously named UEM, where you can dynamically build configurations for users on the fly as they log into the systems. This minimizes the need for GPOs and replication, and also as well can give the user the feeling of persistence, especially in non-persistent desktop builds where those desktops may be deleted when users log out. We also do support user profile context systems such as Microsoft FX Logic, which is a cool technology which kind of containerizes profiles as well. However, that's a little bit newer to the market and may take a little bit more changes in your environment to get up and running so that it works as you need it to. And then finally, one of the big things for me is image management. So at the moment, Horizon doesn't support the use of content libraries, which is using content libraries, you can synchronize images between environments. So unfortunately, there is going to be some manual parts to how you operate the data operations and push updates out into your tools as well. So you need to consider about running those golden images. Do you run separate images in your on-prem environment and in VMC? And if so, how do you update them in lockstep? So that's going to be more about how you control your standard operating procedures for the time being. And again, image management today, I know that it is going to be one of those things that's a little bit tricky for yourselves, but by feeding back how you'd like this to work to your VMware SMEs as well really helps, because we can work with our engineering departments to meet your needs. So for me, the biggest considerations and constraints when running in VMC to an on-prem platform is the networking and security side. When running Horizon, as you've kind of already noticed, we've not really talked about in the Horizon admin console itself, for example, because everything kind of feels and looks the same, but the networking and security piece is really key. So you're going to have to create yourself some LAN and DMZ segments in the VMC console. As you can see by the screenshot that I have for my test environment, I created a DMZ, a network to run my RDS farm, which is linked to Horizon, and then also a load balance segment as well. Moving on to load balancing, VMC is a bring your own load balance environment. So although the underlying platform uses NSXT, the load balancing functionality isn't exposed to the end user. So what options are available? You could use things like AWS Route 53, which is fantastic, especially if you want to use the cloud pod architecture. You could use the AWS Elastic Load Balancer, so again, leveraging those native services of AWS, as the diagram shows here at the moment. But you also need to consider the traffic. So the user will be terminating from the public internet to those native services, and then will need to be passed from that VPC of those native services into your VMware SDDC. Or you can bring a load balancer directly to the SDDC within VMC itself, such as Avi Networks, also now renamed NSX Advanced Load Balancer. The difference being here in the second screenshot is that that traffic will terminate on the compute gateway, as all of your other traffic will within the SDDC, and then the load balancing function is going to happen in your environment. That's also very obvious, but some of the considerations you need to take there is by running them virtual machines on your platform, you're consuming the compute and storage of the SDDC, whereas you may not have those considerations if you're running the native services within AWS. And then finally, you're obviously going to be running desktops up in the environment, and typically nowadays a lot of people go down the non-persistent route, which also means using DHCP. In VMC, the options are very limited. DHCP is available as a relay now, and for an environment, especially where you're looking at running hundreds or thousands of desktops, it's recommended to set up a DHCP on a server running in VMC. Run it just on the subnets that you need, but it also gives you more granular control. Also moving on for the security side of it, we have two types of firewall. So we have the gateway firewall, which looks after north and south traffic. So that's everything entering and leaving clusters or the SEC to the outside world. And then we have the distributed firewall. So this is your east to west traffic or microsegmentation services you've probably heard from the NSX technology, protecting communications between virtual machines. You should see me highlighting that better now at the moment. You need to use the distributed firewall to create a DMZ for your UAG services and load balance services. So what does that look like in VMC? In my environment, I created a section I've put all of my rules going back and forth between my UAGs to the various components of the Horizon platform, so such as my connection brokers, my load balancers. And at the end, it's very simple. I've created 2 rules. So I block any traffic which hasn't already been allowed going to my UAGs, and then finally deny any traffic going from my UAGs to anything else in my environment. This creates a DMZ. If I don't add these deny rules in, then because I'm using routed networks in VMC, my UAGs will be open to route around my network. One of the things I'd also recommend that you do is look at vRealize Login Cloud. You get a limited service offering as part of being a VMware Cloud and AWS user, and you can monitor your NSXT firewall logs up to 1 gig of logs per day, and these are easily sent to LoginSight as built in as part of the service by just clicking the option to enable logs on your firewall rules. And here we can just kind of see in this diagram, I'm querying on the NSXT firewall, and then we can just see some traffic which has been allowed and disallowed through the environment. Okay, so let's wrap up with some final considerations. And again, I will share the links at the end of this presentation because I know I've shared a lot of information so far. Consider your use case. A lot of customers are looking at the data center evacuations being one of the use cases. You may already have an on-prem Horizon environment running on aging hardware. So do you want to use CloudPod architecture to give the user a seamless interface between consuming on-prem resources and resources in VMC? Or will you run them as separate Horizon instances? So again, what versions you run your Horizon environments will help also make that decision. What are your constraints when building this environment? So think about sizing your Horizon environment. How many users are you going to need to support? Then consider the maximums in terms of soft limits and hard limits. How many hosts per cluster can you have within your SDC? How many clusters per SDC? And what regions do you need to operate in? Desktop to host ratio is always a key thing for VMC. So do your users run intense workloads such as multi-monitor setups? If the answer is yes, you're going to get less desktops to host ratio, which then pushes up the numbers of clusters that you need. And then finally, networking. So what's your connectivity into VMC? Are you using things like IPsec VPNs, which will add an overhead into your traffic? Or are you using the AWS Direct Connect technology, which is faster links, dedicated, but also come at a high cost? And some of the resolutions for this. So you could scale out across multiple SDDCs to help with cluster limits, desktop to host ratios, and also as well splitting out maybe that traffic if you're using IPsec VPNs across different tunnels and different connection endpoints as well. If you were to do this across multiple SDCs, as we can see up here in this diagram, then you can also use CloudPod architecture just in VMC to link these Horizon environments together to give you a seamless experience. Okay, thank you very much, everyone, for this whirlwind tour of Horizon on VMC. Again, you can find all of the links at theexpert.me/VMC-Horizon, or you could also scan the QR code in the top right-hand corner. Thank you very much.
Hello, my name is Marco Abella, and I'm part of the Dell EMC Storage Product Management Division. Here today, I will talk to you about running virtualized applications inside a modern storage platform using Dell EMC PowerStore apps on. PowerStore is the next generation mid-range offering from Dell EMC that is built from the ground up for NVMe. Its design principles are centered around 3 main themes. The first is data centricity, with the ability to run any workload, whether physical or virtual, block-based, file-based, or container-based, and a performance-optimized appliance designed for NVMe that can scale up in single drive increments as well as scale out, all with always-on inline data reduction. Next is intelligence, with a programmable infrastructure that enables DevOps and automation through integrations such as VRO and Ansible. PowerStore also has built-in AI and ML, which simplifies typical storage administration tasks, such as optimizing system resources, and also uses it to provide proactive health analytics to reduce risk by predicting potential future issues and needs. Last is adaptability, with a flexible container-based architecture that can be deployed as a traditional external storage array or with VMware's ESXi hypervisor integrated to allow virtualized applications to run directly on PowerStore. This offers flexible deployment models to modernize infrastructure regardless of location, and provides choice, predictability, and investment protection through flexible consumption models and data-in-place upgrades. PowerStore is built around the PowerStore OS, which is a container-based active-active architecture which is optimized for next-generation technologies such as NVMe media, is able to provide multi-dimensional scale with the ability to scale up, scale out, and even scale down, all while providing always-on inline enterprise data services. In following a modern container-based architecture, the PowerStore OS is made up from a group of modular containers, with each container providing a specific service. Examples of running containers in the PowerStore operating system include a container for the control path services, a container for the data path, a container for data mobility, which handles things such as replication, one for serviceability, and even one for file services. This modularity provides two main benefits. The first is the ability to restart and upgrade specific containers without impacting other containers. For example, if a specific library needs to be updated due to a security vulnerability and that library resides in the control path, we can upgrade that specific container without any impact to I/O. Where with the traditional monolithic stack architecture, you would need to take down the entire stack and fail over I/O. Second is the ability to go to market faster with best-of-breed services across Dell technologies. For services that are common across the storage products, rather than have each individual storage product group build their own version of an offering and have it behave completely and have inconsistent experience across the products, we can have a common engineering team that focuses on delivering best-of-breed shared technologies, which when delivered as a container can be easily consumed as part of this architecture, which is exactly what we're doing, for example, with our serviceability and file services. By building PowerStore from scratch, a new data path created around NVMe, we're also able to build new leading data reduction technologies. If you look at the Dell EMC primary storage portfolio today, XtremIO leads in terms of DRR with an average DRR of 3.75 to 1. With PowerStore, our expected DRR is 4 to 1, made possible by having a compression offload and fine granular dedupe that is always on and in memory. And in fact, we are so confident in this that we even guarantee it. Now, PowerStore can be deployed in two primary different deployment models. The first is with a standard traditional deployment model, which is the PowerStore T model, in which PowerStore serves storage to external hosts as a traditional storage array via fiber channel and iSCSI. But what's so radically different about this platform is our hypervisor-based deployment, also known as AppsOn. Now, if you look at the PowerStore appliance and really think about it, the two nodes that run the PowerStore OS and provide the active-active HA capabilities are really just purpose-built servers with each of the two nodes having dual-socket CPUs in memory. With the AppsOn offering in the PowerStore X model, the ESXi hypervisor is loaded onto each of the two nodes, and the PowerStore operating system is running active-active as a VM on each of these two nodes, providing the exact same data services on the exact same hardware. What this allows is local compute to be exposed so that virtual machines can be run directly on the same PowerStore appliance using the same VMware tools to administer this that the majority of companies have already standardized on today. This is ideal for storage-intensive data-hungry applications, OEM solutions, and infrastructure consolidation use cases where PowerStore provides the ability to run applications protected in an active-active HA manner with enterprise data services all in a single 2U appliance. In addition, this deployment model is multi-personality in that apart from allowing applications to run on internal compute, it also simultaneously acts and serves storage to external hosts via fiber channel and iSCSI like a traditional SAN offering the ability to modernize while protecting existing infrastructure investments. Both of these models, the PowerStore T or the PowerStore X with apps on, run on the exact same PowerStore hardware, which is fully redundant dual node appliance with each node having dual socket Intel CPUs that can scale from 16 to 56 CPUs per node and 192 gigs of memory to 1.28 terabytes of memory per node. And again, it's 2 nodes per 2U appliance. In terms of drive support, as the base enclosure of the appliance is all NVMe, supported capacities are 1.92 terabytes all the way up to 15.36 terabyte NVMe drives. And for customers looking for the highest levels of performance, SCM is supported in 375 gig or 750 gig capacity points. Additional drives can also be added via expansion shelves. Now let's look at some deployment scenarios where PowerStore can be utilized to modernize infrastructure starting at the edge. Usually requirements for the edge are low latency, high availability, and small footprints, as these locations don't typically have primary data centers, so space really comes at a premium. PowerStore with apps on is ideal for these edge site requirements, allowing streaming data from devices to be captured at the edge site, with the edge site application running directly on the same appliance for ultra low latency. As mentioned before, PowerStore models support the same core features. PowerStore has built-in native replication, which allows these edge site locations to replicate to a core data center where cross-edge site data can be aggregated and analyzed. And since both models are fully interoperable, the PowerStore X model with apps on can replicate to a larger PowerStore T model residing in the primary data center. By leveraging the industry-leading ESXi hypervisor, we also automatically inherit some core native services that come as a part of it, such as vMotion. Using vMotion, customers can move workloads around from existing external ESX servers onto PowerStore with apps on as needed, including existing HCI solutions such as VxRail as a complementary extension. And remember, the apps on model of PowerStore also acts as a traditional SAN in that it also provides storage to external servers, whether bare metal or virtualized via Fiber Channel and iSCSI. Now let's talk about all the innovation, all the IP that went into the apps on architecture. So first is through work done as part of a 3-way NDA with Intel and VMware. PowerStore leverages Intel's VMD technology for a direct private PCIe domain, which pass-throughs the ESX hypervisor, enabling bare metal NVMe performance. This also provides full support for NVMe plug-and-play, which enables our fully online single drive scale-up capabilities, as well as supporting PCI fault containment. The second benefit, or the second innovation that went into this architecture, is that we solved around a noisy neighbor problem. The PowerStore OS resources, which are used for serving storage, are completely separated from user space resources, which are used to create and run virtual machines, guaranteeing consistent and predictable storage performance at all times so that no resources are trespassed to the other side. Next is the multi-personality, which I talked about before. The PowerStore X model with apps on is multi-personality in that apart from allowing VMs to run on the internal nodes, it also simultaneously acts as a traditional SAN array, serving block workloads to external servers via Fiber Channel and iSCSI. These external servers are external ESX servers. Again, you benefit from inheriting native ESXi data services, such as vMotion, allowing to move workloads around from external ESX servers to the internal ESX servers that make up the PowerStore X model as needed. And next, which we'll talk a little bit more on in the next slide, is a really tight vVol integration that we have spent a lot of time on. So let's spend some time to talk about PowerStore's efficient vVol implementation, which includes some very cool integrations that we have done to give customers the best possible experience with vVols. The first is a turnkey vVol setup. There's nothing to configure. You simply register your vCenter server and PowerStore will take care of the rest, allowing you to use vVols instantly. VASA provider registration, protocol endpoint creation, storage container creation, and even the vVol data store is created automatically. In addition, all data services, such as data reduction services, are fully on and always running on vVols. Next is end-to-end VM visibility, which provides the ability to track capacity utilization, VM compute performance, storage performance, alerting, protection, and display individual vVols that make up a VM. From the PowerStore manager, a user can view all these VMs running and utilizing vVol storage from the PowerStore array. Next is integrations with VMware's SPVM. We currently expose quality of service through SPVM, and we will continue to expose more and more storage policies in the future, such as local protection and replication. And last is integration with managed snapshots. Snapshots can be taken on demand or via a protection policy assigned to a VM from the PowerStore manager, which are then displayed in vCenter, meaning if a snapshot is taken from the PowerStore manager of a vVol-based VM, those snapshots are visible in vCenter by right-clicking a VM and do manage snapshots so that a VMware administrator has access to them as needed. But it's also vice versa. A snapshot taken from VMware via right-clicking a VM and selecting Create Snapshot, those same snapshots are displayed and available in the PowerStore manager. But our VMware integration doesn't stop with vVols and truly is unmatched. In addition to our vVol integration, we also have integration with VRO for automation, along with PowerStore being supported as an external storage array to workload domains under VMware's VCF. Last, I want to display a use case highlighting the power of apps on in a customer scenario. So an example of PowerStore with apps on in action is in the healthcare space. Medical informatics offers a suite of applications called SickBay that unlock over 300 data points created by bedside devices, from heart rate monitors to ventilators. All this data is collected at the edge and then both stored and streamed to both local and remote nurses stations where multi-patient monitoring can happen from a centralized location. This requires a solution that can provide ultra-low latency, high storage to store years worth of patient data, and is easy to use, and provides high availability in the smallest possible footprint because these locations, again, don't have typical primary data centers. Leveraging PowerStore with apps on, the SickBay application suite can run directly on PowerStore, taking advantage of both local compute and enterprise storage in a single consolidated system. Typically, patient data disappears within 48 to 72 hours, but now leveraging SickBay and PowerStore, data can be kept for much longer so that a trend can be created for each patient to provide new insights. Streaming data can be collected at the edge from bedside devices and placed in front of a physician in real time while ensuring performance and availability in a small footprint. This is the power of apps on. Thank you very much, and I hope you enjoyed this session.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to take a look on NSXT 3.0 and what we can do with that. So NSX 3.0 has 3 main use cases, and we're going to talk about each one of them. The first one is automation. As automation, we can understand that as network virtualization. So create like logical suites, logical routers, logical firewalls. We can like create those on our virtual infrastructure or align with a broader automation strategy with VRA, VIO, or like Kubernetes. The second use case is security. So increase the security posture inside the data center, applying security rules to the east-west traffic, or like to the traffic that's coming in and out from a VM or a container. And the third use case is the business availability. So NSX can stretch the data centers and easily provide like multi-site architectures and disaster recovery strategies. So we're going to start with the first use case, that's automation. The benefit of NSX for automation is that it's a single endpoint for network virtualization. So here in the left, we have like VRA, VIO, vCloud Director, Kubernetes, Terraform, can also have Ansible and other platforms. And those orchestrators will deploy VMs and containers. However, for those workloads to communicate, we need to also provide networking. So NSX will provide layered firewall, security, network connectivity, routing, and also load balance. The other thing that's really good about NSX is that it also has governance among all those objects. So when it creates a logical suite like a layer 2 network, it will know what's connected there, and when the workload is removed, that connection is also removed, and together with all the firewall rules that belongs to that object. So this way we can control the life cycle of like a workload or like any application. To start with automation, we do our Hello World in NSX. In this case, the Hello World is a layer 2 network. We're gonna create a logical switching, and we're gonna connect 2 workloads here, Web 1 and Web 2, and we're gonna do that in the NSX UI. Here we are in the Web 01. We're gonna try to communicate to Web 02. The communication doesn't work, so we're gonna create a new network called Web, and create that on NSX in NSX UI. After that, we can go to vCenter and connect both workloads in the same network. The network will be available in NSX UI, and we just need to consume that object. After connecting both VMs in the same network, the communication works. So we have layer 2 connectivity between Web 01 and Web 02. The next step is the routing. So the communication between workloads connected in different subnets. To do that, we're going to use an object called T1 gateway or T1 router. It will be the default gateway for each one of the segments that will be created in NSX. T1 gateway or T1 router are kernel-based routers. So they're going to be distributed routers that will work at the hypervisor layer. This way, we're going to have the same IP address for routing, like in all networks, in all the hypervisors that are part of the NSX domain. In this case, we're going to create a T1 gateway that will be the default gateway for segment web and also for segment app, where we have the app01 VM. Here we are again in the web01, and we're going to start to ping the default gateway. We don't have a T1 gateway yet. We're going to create the T1 called T1 vBrownBag. After creating that, we just need to configure that as a default gateway for our web network. Here I select my T1 and I choose the IP address that will be the default gateway. After configuring that, I successfully can ping the default gateway, and I will start to ping other network, in this case, the app network. I'm gonna configure that network to use the same T1 gateway and configure the IP address. After that, we also have connectivity between web and app in a router basis. After that, we need to figure out how this virtual network will communicate with the external world. So to do that, we're going to have a router here called T0, and we're going to connect the T1 with T0, and here we're going to share the routes using a mechanism called routing plumbing. This will automatically redistribute the routes that are connected, and also can redistribute the routes that from NAT and for load balance, for VPN, and also can create route maps to select which route we're going to redistribute automatically to T0. And after that, the T0 will redistribute, will exchange routes with the physical router using BGP. In this case, I will try to ping my web01, and I can see the ping doesn't work. So I'm gonna access my T1 gateway and connect that to T0 and select the connected segments to be redistributed. After that, I can ping my web01 successfully. The next step is the security. So the security part we can use with overlay or not. We can deploy a security posture in the environment, like in the data center, even without using NSX overlay, which means that we can deploy that using a regular VLAN. In this case, we have like two VLANs here. We have the VLAN 100 and the VLAN 200, where we have vSphere workloads, also KVM, Kubernetes, and some bare metals here. So what NSX will do, it will deploy element called DFW. DFW is the distributed file of NSX, and it will take a look, actually it will enforce the security posture at the VNIC level or in containers at the CNIC level. This way, if you have like a communication that's not allowed, you will block that communication at the nearest point of the application. In the case of a pod, it will block in the pod port. In the case of VM, it will block at the VNIC. It will also can in our environment, we will deploy a security rule that will block the communication between web and app, and you will allow the communication of like HTTP. here we are at the Web01, and we're gonna ping the Web02. The communication works successfully. We also can do an SSH, and you can also access that using curl. So here I have the our distributed firewall. I'm gonna create here a section called DFW vBrownBag, and I'm gonna include some rules here. So here I'm gonna create a new security group. The security group will be called Web vBrownBag, and I will select the members. So I will select the members based on VM. I also can create like dynamic rules to include the members dynamically. This way I did it manually, so those VMs will be statically belong to that group. And I'm gonna create also two other rules here, allowing HTTP traffic either in L7 and L4. And something that's really nice about this UI is that it has a drag and drop, and it's a HTML5 drag and drop, and it works really well. So here I'm allowing the HTTP for L4 and L7, and after that I can try to ping the communication. It will be prohibited. And if I try to do also an SSH, it will be prohibited. However, the web application still works either from inside or the outside world. The next step is business continuity. So we can use NSX to extend our data centers and easily deploy a disaster recovery strategy or a multi-site strategy. In this case, we have two clusters here, cluster A and cluster B, and they are different clusters. In this case, we're using the same vCenter for those clusters, but they can be different vCenters. In the version 3.0, I think we can integrate up to 16 vCenters to NSX. And so having the work like the processing, the hypervisor layer identical, you're gonna use the NSX to provide L2 connectivity between the data centers. This way, we only need to do a vMotion to have that workload running in the other data center, and all the network parameters like IP address and DNS entries or DFW rules will be maintained in the second data center. For north-south traffic, in this way, we are using like an active standby where we have edge node for T0 active in site 1 and a standby node in site B. To do that, this way you have a maximum latency of 10 milliseconds. If you have less than 10 milliseconds, we can use that. Otherwise, we need to provide other kinds of strategy for north-south. And also, the edges are exchanging BGP with like the physical layer. And once the edge node edge node 1 got failed, and the site B will start to use the edge node 2 as active, doing BFD. So BFD allows the fast converse between fails. What we're gonna do for our testing, we're gonna start a ping to Web01, and after the ping, we're gonna do a vMotion and see how the L2 stretches across sites. So here I'm doing the ping to Web01, and I'm gonna to migrate my Web01 to the site B. Here I'm going to select the host in site B that I want to host that VM now. In this case will be Web01. The network will be the same. And after the vMotion, we can see here that the vMotion worked successfully and the communication didn't stop. That's all I have. Thank you very much and see you next time.
Good afternoon, good morning, good evening, wherever you are. My name is Mark Stockham. I'm a field CTO with Dell Technologies Data Protection Solutions, specifically working with VMware technologies. And today we're going to be talking about data protection for multi-cloud in VMware environments. So what do we mean initially by multi-cloud? Multi-cloud for us in this context is those on-premises, those hybrid, those multiple public clouds, any or all of the above, being able to operate in all of those clouds and give data protection solutions regardless of where the workloads run. Which hyperscalers are we going to be talking about? Primarily AWS, Azure, and GCP and Google. There are others that we'll touch on, but primarily those three. The most appropriate use cases will be covered for data protection relating to all of these clouds. We'll discuss optimal architecture. We'll be looking at some of the critical workloads, and we'll also touch on automation elements for reasons that will become apparent a bit later on. So to start off with, what are the most appropriate use cases? Today we're going to be talking about long-term retention to start off with. We'll then be moving on to cloud disaster recovery, backing up into the cloud from on-premises environments, and also backing up from within the cloud itself. In all of these scenarios, we're going to be looking at it from a data protection storage perspective, so the data domain, be that a physical appliance, a converged appliance, or a virtual appliance, and looking at things also from a data mover perspective, so the data protection software itself. In all of these scenarios, performance, efficiency, and the ability to operate in the multiple clouds, Amazon, Google, Azure, as well as VMC, etc., are going to be addressed in the use cases. So, first scenario, long-term retention to the cloud. In this case, we're going to be using the cloud to give us the ability to hopefully reduce our reliance on tape, on those less accessible mediums, those things that take us longer to get data recovered from. So we've got the on-premises environment, we've got an active tier carrying out operational day-to-day protection and recovery. We're taking some of that data that has aged out and we're moving it to the cloud tier. We have a long-term retention tier, if you like, using S3 compatible storage. So in this case, looking on premises at something like Dell EMC ECS, Elastic Cloud Storage. But the topic for today is, of course, the cloud. So equally, we can take that deduplicated, that compressed, that encrypted data, and we can move it into the public cloud. Use a public cloud provider purely for their storage. So we have the ability to use AWS, Azure Blob Storage, AWS S3, Google Cloud, various other clouds, purely to give us that storage capability. So we're taking the highly efficient deduplication that the data domain gives us in the first place. We're able to take that policy engine, use that policy engine to decide what we're going to move to the long-term retention, the cloud tier. We can scale highly based upon the physical appliances that we can deploy. We can also use a data protection appliance like a PowerProtect DD series 3300, 4400, giving us an entry point, much lower entry point. And we can take, even if we want to, a virtual appliance, a DDVE, and start at something like a 1 terabyte incremental increase of storage, and deploy that and use that as the on-premises storage. We can support third-party data movers, but obviously better deduplication is achieved with Dell Technology Solutions, and this helps us to move away from the likes of tape. So this is an entry point, if you like. This is using the cloud environment purely for its cheap storage. Moving on to the next level, cloud disaster recovery. So taking your virtual estate, your VMware estate that runs day to day, taking that environment, protecting the data onto a data domain on premises, be that physical, appliance, etc., and then taking some of that data and pushing it again into cloud storage. In this case, Amazon S3, Azure Blob, and making sure that we have copies that are available in the cloud. Should we want to spin that workload up in the case of a disaster recovery, we can convert that image, we can pre-convert it, or we can convert it on the fly and run it as an EC2 instance. The same thing can occur for Azure, so we can convert it to an Azure VM image and run it there. Pre-conversion also available should we need to or want to. But if we do want to run it just as another VM, if you like, we can also leverage VMware Cloud on AWS and just run that, or just take that image, bring it up, restore it into as a VMware VM, and we can then run that in the cloud, carry on running, and then should we need to move that workload back on-prem after the disaster has passed, we can vMotion that virtual machine back on premises. So we've got two options. We can take the option to run it as an EC2 or an Azure image, or we can run it in EC2. What this means is we've got this orchestrated failover capability into the various clouds. Recovery can be minutes. If we pre-convert some of these images, pre-conversion can be run on a regular basis. Once that image is uploaded into the cloud, we're able to recover in minutes. We can have recovery point objectives as short as 15 minutes, seamlessly integrated with what's going on premises, and application consistent recovery is available in Amazon itself. So this can replace a secondary or a tertiary data center. I've seen this in a lot of cases throughout EMEA, which is the region that I cover. So can obviate the need for making high physical hardware purchases, and also the cost of facilities managing entire premises. So what about if we want to actually back up from on-prem into the cloud? What does that look like? Of course, we've got the usual efficiency of DD boost. We deduplicate to the client side, we compress, we encrypt. That information is protected on premises. We could then take that data and move it into a data domain virtual edition, a PowerProtect DD virtual edition, running either in Google Cloud, in Amazon, or in Azure. And this gives us the ability to leverage the lower cost of running natively in those cloud environments. Being able to run in EC2, for example, is much, much cheaper than running in VMC. What we can get here is the ability to write directly to that storage appliance. We don't need to have storage on-prem. We could. There's another scenario coming up shortly in which we cover that use case. So we don't need to use on-site storage. Boost takes a lot of the pain of ingress, of moving data from on-prem into the cloud, and it gives us a multitude of deployment options. Use case here could be a remote site with a very small footprint, not enough footprint to deploy even a data domain virtual edition or a small appliance. If you have limited WAN capabilities, the ability to carry out this client-side dedupe allows us to minimize the amount of data that gets transitioned. And the facilities on site may not be suitable to host data protection storage. It might just not be suitable. So this is the scenario that we see in a lot of cases, customers wanting to take the data, move it out, and store it initially in the cloud. So just jumping very briefly into an architecture slide, the architecture we're taking into consideration here is the use of virtual proxies, client-side deduplication, giving us the ability to do change block tracking from a VMware perspective, and take as little data as possible to move it across the network, to then let it reside on the highly efficient protection storage, giving us minimal footprint. We'll cover why that's important very soon. But the highlight here is, whenever you move to the cloud, between clouds, between zones, availability zones, regions, et cetera, or when you egress, obviously one of those hidden costs is the cost of moving data. The less data you move, the better things tend to be. And also, if we're doing this from a software-defined perspective, automation is something that we can leverage, and we'll come on to automation in a few slides' time. What we can also leverage here is a lot of the in-stack and vRealize automation capabilities of the stack, and that data efficiency really does pay dividends when we're not just on-prem, but also in the cloud. So what about if we have existing platforms that we're running on-prem and we want to replicate that data elsewhere? Well, again, the efficiency that we have as part of the platform, the deduplication, the compression, the encryption, allows us to take that data and then just carry out a replica between the on-prem environment and the PowerProtect DD Virtual Edition running in either GCP, AWS, or Azure. And what this means is we're able to take that data and get it into the cloud in as quick and as efficient a manner as possible. Some customers just want to be able to move their data and get it into the cloud so that they can leverage it and replicate it elsewhere. We've got the ability to support third-party software should we require it here. Very easy to deploy through the various different marketplaces. Latest and greatest versions have been released in the past week or two on some of these platforms, and this means that reduces that ingress-egress cost, means that that bill shock is reduced or minimized. So what about where we have VMC, VMware Cloud, for example? In this scenario, we've got the on-premises environment. It's running as you would expect, all your virtual machines, vSAN, ESX, NSX, etc., etc. We're also able to configure and run the environment in hybrid link mode, so we have that VMC instance that looks, smells, feels exactly like what's being run on-prem. So that's great from the perspective of being able to run workloads either on-prem or in the cloud in a hybrid and a seamless fashion. But from the data protection perspective, what we really want to be doing is making the most of the adjacency that we have between the VMC instance and the native Amazon facilities that reside next to it. In this case, we're able to run PowerProtect DD Virtual Edition as an EC2 instance using S3 storage. And because it's sat literally next door to the VMC instance, we've got high bandwidth, we've got a variety of methods of connecting to it, which gives us the ability to drive down cost for protecting those workloads that reside in VMC. We could equally run it in VMC, but it's a more cost-efficient option to deploy in native Amazon. What do we get here? Yeah, enterprise-class data protection for VMware Cloud and AWS. We get that image-based protection capability, instant recovery of those workloads either within the VMC instance, or we can vMotion them or just run them on premises. We've got the ability to store in S3, which gives us that cost benefit, and it's a consistent and seamless operation experience for the VMware operator. We'll come on to that a little bit later on from an automation perspective. What about when we're protecting workloads from an in-cloud perspective? So in the scenario here, we have a multitude of applications that reside on-prem or in the cloud. In this case, cloud applications. We have a specific set of application tools that allow us to take that data and move it from the client directly to PowerProtect DD Virtual Edition residing in Azure, Amazon, Google GCP. The ability to take that, leveraging all of the existing benefits, the deduplication, et cetera, the minimization of network traffic, and fundamentally giving higher performance, lower backup window times, being able to manage this stuff on-prem and let it reside in the cloud. And a lot of the deployment capabilities are available through those marketplaces. So it makes a lot of sense to be able to leverage the benefits of being able to run PowerProtect DD Virtual Edition in the cloud on whichever cloud provider you want, and be able to protect those various workloads that you are interested in. Not forgetting the likes of Kubernetes that are covered in other sessions and other topics of much discussion elsewhere, but are also protected by our PowerProtect suite of products. mentioned earlier on about the low cost footprint. Just a very brief slide here. The way in which we deploy in AWS, for example, natively on EC2 is a much more efficient from a deduplication perspective. So we're able to store much less data to protect the same workloads. We're able to use less compute instances, so the cost of EC2 compute will be lower. The cost of storage will be lower from a block perspective, and the cost of object storage will also be low based upon the lower footprint. And you can see some comparative costs in here, but just to make the point that it's not just about the minimization of the network traffic that we mentioned earlier on, but also if we're running natively in the cloud, we're able to drive down costs there too, which is obviously a key driver for most customers moving to the cloud for cost reasons. Now, all of this would be slightly irrelevant if we didn't have a way of managing the entire environment. So we're able to use Data Protection Central to get a single view of what's going on throughout the environment. A number of ways in which we can deploy and utilize this. This is not the only way in which we can do this. We also have the ability to tie into the likes of Tanzu Mission Control, but that's a topic for the cloud native side of things. Just want to make the point that all of this needs to be visualized and managed in an effective fashion. And while we're speaking about management, it'd be remiss of me not to mention vRealize automation. So taking the scenario we just mentioned where we had on-prem, we had VMC, and we've got the native EC2 data domain running in EC2 natively, we also have the ability to tie into vRealize automation. So vRealize automation being that element that gives us full lifecycle management of those VMs, regardless of whether they're running on-prem or in VMC when we're in that hybrid link mode. Now we have a comprehensive set of vRealize integration capabilities right now, regardless of which data mover that is being used. But the product management have asked me to give you a sneaky peek into what's coming soon, what's coming next. So as you're no doubt aware, vRealize 8.0 released earlier on in the year. vRealize 8.2 integration for our data protection extension will be published shortly. What this will allow us to do is give customers, yourselves, the ability to create policies which can then be exposed through vRealize automation and can be attached to virtual machines, giving us those day two operations for protecting, backing up, restoring to new and various other tasks that you'll be familiar with from vRealize Automation 7 that we will be the first to promote, to produce for vRealize 8.2. That's something that will be coming out later this year, but watch this space. This should be the first you've heard of it. So in summary, what we're talking about from a data protection perspective are solutions that map across all of the VMware cloud delivery options, regardless of whether you're on-prem private cloud, whether you're using some sort of subscription model, VMC on Dell EMC, AWS public cloud, GCP, Azure, etc. All of these delivery options are covered. We can protect workloads in those clouds, from those clouds, replicate to, restore from, in addition to the obvious Kubernetes, Tanzu, vRealize integrations that we've mentioned also. And this technology that we use, the architecture that we use, gives us a significant benefit right now. And watch this space throughout the whole of VMworld. Look for Dell Technologies data protection solutions and see what's coming next, what we'll be announcing, and what's coming next to further enhance the way in which you can protect your workloads when they're running on any of these VMware platforms. With that, I'd like to thank you for your time and your attention. And if you do want to get in touch, my name is Mark Stockham, mark.stockham@dell.com. Please feel free to reach out, and I'll be happy to answer any questions. Thank you very much for your time and attention.
Hey, this is Shashi from PowerFlex product management team, and I mainly focus on developing applications and workload solutions for PowerFlex. And in today's session, we'll talk about some specific use cases and applications for high-performing machine learning solutions like Elastic Stack on PowerFlex with VMware. So just a brief update or a brief summary of what is Elastic Stack and its use cases. So Elastic Stack, previously known as ELK Stack, is kind of a combination of 3 different modules, open source modules. One is the Kibana, Elasticsearch, and then also the key other module is the Logstash. Again, the Kibana is the component which again mainly handles the visualization and manageability. And then the Elasticsearch is the open source tool which takes care of the entire data ingestion, enrichment, and then also the storage analytic operations. And then the Logstash is the component which kind of takes care of all the ingestion and then again feeds that ingested values into the Elasticsearch, and Kibana helps in the visualization. So all these 3 components together is called as Elastic Stack, which has become very popular now for customers who are challenged with really exponentially growing, very mission critical and high throughput intensive machine language and analytic applications. So why again customers are interested in Elastic? Like first thing is again Elastic is open source. Again it is definitely becoming very popular. Again, a lot of customers are looking for alternatives. There are some leaders in this field, but again, customers are looking for alternative because machine data analysis is becoming more expensive and then also very challenging with respect to performance and also other throughput and scalability requirements. So they're looking for a more efficient way of handling this kind of data. And then also they're looking for platforms or infrastructure which can be scaled easily and then also provide some kind of a really predictive and then also predictable performance and then also with respect to reliability and other benefits. So these are the key challenges again customers are looking for, and then Elastic is one of the very popular open source tool, which is again gaining really good traction. And then again, customers are looking for deploying this kind of deployments on containers with virtualization, because that's the way they can actually address a lot of challenges with respect to these customers, because they have that kind of flexibility now wherein they can actually manage different kind of or different challenges with respect to performance with different applications and containers and also the VMs. So let's talk about PowerFlex. Dell EMC PowerFlex again is a software defined storage. Again, the 3 key tenets are harness software, embrace change, and deliver predictability. Again, when I say harness software, Dell EMC PowerFlex is the software-defined storage, which is really known for its performance, scalability, and fluidity benefits. Again, when I say embrace change, the other pillar is the deployment options PowerFlex provides, and then also the different options with respect to the platform support, whether it is 2-socket or 4-socket, and then also the consumption models, whether you need a completely engineered system or an appliance model, wherein you can bring in your own networking. So you have all that flexibility and deployment options with PowerFlex. Again, the other key tenet for PowerFlex is the predictability. You get 6 nines of availability, and then also the automation which you get with PowerFlex Manager, which is the orchestration software, is very unique because it can actually provide end-to-end automation and orchestration capabilities for your entire stack, including networking, storage, and compute resources. And whatever is your challenges with respect to workloads, whether it is performance or reliability, PowerFlex can provide you that kind of predictability. So they get a little bit more details on the PowerFlex software-defined storage. Again, PowerFlex is known for performance, scale, and resiliency. How does it provide that kind of massive performance? The PowerFlex can provide that kind of unique, massive performance because of the architecture, the unique architecture which PowerFlex has. On a PowerFlex system, every node on the cluster, including every drives sitting on those nodes, actually contribute with the I/O operations. This is one of the main reasons why, because of this aggregated resources, you get millions of IOPS with sub-millisecond latency. And then also you get the same kind of throughput. And then also when you scale your environment, because all your nodes and drives are operating, are contributing with the I/O, you get the same kind of benefit without any latency impact. When I say scalability, I talked about the key benefits with respect to latency and also the performance benefits. Again, as you can see, you can start probably with the 4 nodes, a very small footprint of 4 nodes, and then you can grow up to like hundreds or even up to 4,000 nodes. We actually have customers who have more than 11,000 nodes in their infrastructure data center, and then also with almost up to 300 to 400 nodes on a single cluster. So PowerFlex provides this kind of unrestricted scalability. And then again, whether you use 4 or 400 nodes, you get the same kind of benefits with respect to performance and without any latency impact. And the other key tenant or the key unique value add or the differentiation with PowerFlex is the resiliency. Whether you use 4 nodes or 400 nodes, as I mentioned, you get the same kind of performance. Again, the other key thing, which is very critical for a database administrator or a analytic administrator, is the reliability of the storage. So on a PowerFlex cluster, if for some reason, if there is a planned or unplanned outage of a node, then the administrator or the application administrator does not need to worry about that. The PowerFlex storage will automatically take care of rebalancing the remaining I/O operations, all the I/O operations on the remaining nodes, and then also it will make sure that the I/O is completely rebalanced on the other existing nodes of the cluster. Again, similarly, once that node becomes online, it will automatically make sure that the I/O is completely optimized by rebalancing across all the nodes available on the cluster. And the other key thing I think which I mentioned as one of the tenant of PowerFlex is the flexible deployment architecture. So PowerFlex offers a unique architecture called a disaggregated or 2-layered architecture, wherein you can have your compute and storage resources independently managed, and then also independently you can scale them based on the need. This is very unique architecture by PowerFlex because especially in analytics application, typically you don't need to scale your compute resources all the time. There is always a lot of data being ingested to the system, and then most probably your scalability requirements are only with respect to capacity. So in this kind of scenarios, you can actually independently scale your storage nodes and then keep your compute nodes as it is. Or in case if there is a requirement, you can also increase your compute resource as per the need, which is going to give you a very predictable and then also very cost-effective architecture for analytic applications. And also if there is a need for you to have all your compute and storage resources as a single system, as like a hyperconverged model, PowerFlex even offers that, and then also it supports that. And then also a lot of customers start with a hyperconverged configuration for some specific use cases, and then based on the need, you can actually add only compute resources in a 2-layered architecture as per the need. So as you can see, PowerFlex can provide you all these different kind of deployment models based on your need with the same infrastructure. And the other key thing I just wanted to highlight here is whatever is your application, whether it is like a very high throughput intensive application, like analytic application like Elastic Stack or a SaaS grid, or any databases or any other cloud native or container based applications. And you can deploy that on PowerFlex on the same infrastructure, and then that is the kind of flexibility you get here. So as you can see, PowerFlex can support bare metal configuration, wherein you can deploy some applications like Oracle RAC or any other traditional databases, or you can even have native applications running on containers, or you can even deploy virtual machines. And then also, if required, there are a lot of use cases where customers would like to prefer deploying containers on top of VMs for specifically addressing some isolation and security aspects, and even that is supported on PowerFlex. So you can see the kind of broad platform support PowerFlex provides for analytical applications and then also other mission critical applications here. And then also PowerFlex provides some of the very features which is very relevant, and then also which is required by large mission critical applications like native replication and compression, which are very effective for managing your huge ingestion and then also the growth in analytic applications like AI/ML and other cloud native and then database applications. So let's go into detail of little bit of specific validation and then also some of the reference architectures we have developed with Elastic Stack on PowerFlex with VMware and then containers. So we have a reference architecture. This is a partner validated solution. We worked very closely with Elastic team here, and then we have come up with we have validated a solution wherein PowerFlex was used as the storage infrastructure, and then with VMware Hypervisor, we use Kubernetes containers on top of VMware Hypervisor to deploy the entire Elastic Stack components, which is Logstash, Elasticsearch, Elasticsearch, and Kibana, and all those components which I explained previously were deployed on top of VMs here, like on the virtualized VMs, and then again, ESXi 6.7 was used here as the hypervisor. And then again, this solution actually is completely validated, and then also it's not just, when I say validation, it's not just a validation of the architecture. We also did a quite detailed performance benchmarking on this solution to see what is the kind of value, because there is always a question by a lot of Elasticsearch or any analytic applications, analytic customers saying that, hey, if I virtualize this kind of environment, especially this kind of throughput intensive applications, what kind of performance can I expect? Because they're always worried about this kind of throughput intensive applications. Again, there was always a concern. So we have done like detailed performance benchmarking with the tools, which is completely the industry standard tool, which is developed by Elastic to make sure that what workload we are simulating is very realistic here. So as you can see on this ESXi 6.7 based PowerFlex cluster, with this cluster, we were able to achieve more than 1 billion events within 3 hours. Again, this is again a very basic 4 storage node cluster. As you can see, it's a very starting point of a PowerFlex node cluster with a 4 node storage only cluster. We were able to hit more than 1 billion events within 3 hours. And then again, this is the kind of performance you can get. So these numbers are like phenomenal. And then as you can see, again, when we grow your PowerFlex nodes from 4 to 8 or again more than that, you can get the same kind of linear scaling and linear performance benefits. So again, the other advantage, as I mentioned, is you can even scale only storage if required, or you can scale compute only if required based on your needs. So these numbers are again available in the link what I'm sharing in this. So you can go into the details of that white paper and the detailed reference architecture which I showed here, and then you can get all the details about other key performance numbers which we were able to get from this testing. Again, as I mentioned, like why PowerFlex for Elastic? So PowerFlex, as I mentioned, is known for its high performance and scalable block-based storage, which is really ideal for applications like Elastic Stack, because Elastic Stack customers are looking for this kind of high performance, scalable solution wherein they don't have to worry about the challenges with respect to scalability and the daily ingestion. And then also if they need to scale, how easily they can scale without any, worrying about what needs to be done at the storage side. So, and they can focus entirely on their application and tweaking the application for day-to-day operations. And then the other key things, again, as I mentioned, is PowerFlex supports any hypervisor, including VMware, or you can even do bare metal or even on containers. And then the scalability of compute and storage resources independently is one of the key really key factor. And the other thing I wanted to highlight, especially with Elastic Stack solution, again, Elastic is a GCP partner. Already the Elastic Stack is available. The entire Elastic Stack is available through GCP partner today on GCP Marketplace. Again, a lot of customers are looking to deploy this on top of containers. And then there is a lot of traction happening in this area. And then PowerFlex is already validated for Google Anthos. And then already there are work going on, and then there are some POCs and investigations, and then more work happening wherein we are investigating and trying to validate solutions where you can deploy Elastic Stack on top of containers with PowerFlex. And then also Google Anthos is one of the solutions we are validating. So just to conclude here, again, as I mentioned, for Elastic Stack especially, we were able to achieve 1 billion plus events with just a 4-node storage-only configuration with 3 compute nodes, and again with 3 hours. So this is with Elastic Rally benchmarking tool. And then again, as you can see here, it's not only analytic applications, like again, Elastic Stack and SAS Grid, as you can see, are some of the examples for analytic applications here. But even other applications, whether it is like a traditional database like Oracle or SQL, or even a NoSQL database like Cassandra, you can get the same predictability, or you can get the same performance benefits and the scalability benefits for these kind of applications on PowerFlex. Actually, I just wanted to highlight here that I'm covering some of the specifics or more details on some of these traditional databases and NoSQL databases, how you can deploy and what are the benefits with PowerFlex in another vBrown session. I'll be really happy if you can please also join that session, and then if you have any questions, please let us know. And then again, I just wanted to highlight the resource link here. Again, this is the detailed reference architecture, partner validated solution, which we have done with Elastic. Again, this has all the details with respect to what are the guidelines, and then also the sizing. And then also it has all the details with respect to the performance results, which I shared, like how we were able to get this kind of performance. And then also some more details about the test configuration, and then other test tunable parameters and all the details here. Again, I just wanted to end with a customer testimonial here. Again, PowerFlex, as I mentioned, is already, again, we are seeing a lot of traction of deploying this kind of AI/ML or analytic applications with PowerFlex. Again, we have a large North American bank. Again, they were really impressed when they were able to ingest more than 25 terabyte in 18 hours with just 5 VMs. That's what I wanted to highlight here. It's just 5 VMs, and then they were able to get 25 terabytes. So this is the kind of performance you can get. And then also the other scalability and linear scalability and the reliability benefits complements this. So this is a really great solution for analytics and any machine language or any kind of AI/ML kind of workloads. That concludes my session. Thank you.
Hello, everyone. Thank you for joining. My name is Jason Bakke. I'm a storage development principal engineer with Dell EMC. I've been with the company about 9.5 years. In this session, I'm actually going to talk about and actually demonstrate the migration of VMware's vCloud Director from a traditional Linux cell with an external Microsoft SQL Server database to the embedded Postgres SQL database within a vCloud Director 9.7 appliance. A little background information on this environment that I'm using for the demonstration. This is an environment I built for our technical marketing group about 9 years ago. I deployed it. I've been maintaining it over the years, upgrading it. And like many VMware products, early on, we used a Microsoft SQL Server database backend. And so I've been using this, it's actually on SQL Server 2016 today. But what's important to note is as of VMware vCloud Director 9.7, Support for the SQL Server backend database externally, that goes away. So we need to shift this environment to PostgreSQL with the embedded vCloud Director 9.7 compliance. So I'm actually going to perform both of those steps in one shot here. The migration to the appliance off the, I think it's a CentOS cell that I'm using today, as well as some embedded PostgreSQL. It's actually not as complicated as it might sound. I've actually been through these types of migrations 3 different times. And this is the 4th migration that I'm performing. You simply follow VMware's documentation. The documentation is very well laid out, and it boils down to 4 major steps. And you can see those on the screen on the presentation display here. Step 1 or stage 1 is upgrade the existing environment to vCloud Director 9.7. That's important because VMware wants us to be on the same exact version for the existing cell when we make that jump to the new appliance. So the second stage is to deploy the new vCloud Director 9.7 appliance. The third stage is to migrate the SQL backend database to PostgreSQL. And then the last step or last stage is to copy any shared transfer service data, which we will do. And optionally, if you use certificates beyond just the self-signed certificates, we need to migrate those as well. I do not demonstrate the certificate migration in this video, although that is a fairly easy and well documented step. So we're going to go into the lab demonstration now, and we're actually going to watch this migration and deployment take place. So again, the first stage is to upgrade our existing environment to vCloud Director 9.7. Now, in the interest of time, I have a 15-minute presentation slot here. I've already actually gone ahead and upgraded my existing cell. I've been through these upgrades many times over the years. You've probably been through the upgrades. Here, I'm just going to go and verify that we're on version 9.7, which is going to be the version of the appliance that we're going to migrate to. I'm also going to just kind of float around, spend about 30 seconds here, just checking the health, make sure that my vApps are up and running. There's no error messages. We get a couple different looks here at the vApps that are deployed. And those are the types things that I want to see when we're done with the migration. Here I'm going to use an application called Dell EMC Replay Manager. I want to make sure that I have a good snapshot or backup before we go through the migration. So I use Replay Manager. As you can see, we're quiescing the virtual machines that I'm using as a backup. So I have a point-in-time backup of not only the vCloud Director 9.7 cell, I also have a backup and a application and data consistent snapshot of the SQL database. And here you can see, using the Dell EMC plugin, I can verify that I've actually just taken a snapshot of both in their application and data consistent. Stage 2, we're going to deploy the new vCloud Director appliance. Now, before I do that, you'll see in the documentation steps that VMware has, and I'll post the link at the end of the video here. We need to create a new NFS share for the vCloud Director shared transfer service data. For this particular environment, I'm actually using a Windows NFS share. So I'm creating a new share here, allowing no root squash for that share, which is important. Click apply. Okay. And we'll actually go back and revisit the screen a little later after the deployment and verify that the vCloud Director, the new vCloud Director cell, has actually written the information into there. It's very important that that shared transfer space is working properly for the health and well-being of the vCloud Director environment. Now I'm going to open up a web browser, and we're going to go ahead and deploy the vCloud Director 9.7 appliance. Okay, so I used some time compression here. I think I used 8x. This is simply the deployment of an OVF appliance, and this step actually takes about, I want to say, 10 minutes or so, not only to fill out all the information, but for the completion of the deployment, as well as we're going to actually power on the vCloud Director cell, watch that boot up, and then we'll pick up where that leaves off. But I'll show it all here. You can see I'm not skipping anything important. So our vCloud Director cell has now deployed. The first thing we need to do now is to power it on, and I'm going to open up a web console and just kind of watch the boot up sequence. You will see a couple of error messages there. That's quite normal. But it's going to, upon first boot, it's going to run some post-deployment scripts or installation scripts based on the information that we provided in the deployment of the OVF. And again, I use time compression here because it's not a good use of time to sit and watch that. I wouldn't be able to finish this video within 15 minutes. So you can see our cell has deployed. We're at that blue screen at the end. That signifies that we're done. And we can now actually open a web browser and go to the vCloud Director provider page. And I'm doing that now. So we're going to log in for the first time as administrator. There's no other accounts linked to this provider instance. We've provided really no configuration, and we've not imported any configuration from our previous vCloud Director cell. So this deployment is happening in parallel, and then in the third and fourth steps, we'll migrate over the database and bring over the configuration data. So you can see just by looking at the screen here, this is an empty, unpopulated cell waiting for configuration. I'm going to actually SSH as root into the new cell. And the first thing we're going to do, again, I'm following VMware's documentation, very good documentation on these steps. We're going to stop the vCloud Director service. First, we'll check the status, but we will end up stopping those. I'm getting ahead of myself. We're checking the status of vPostgreSQL. And now I'm going to tail the cell.log. Really what I'm looking for here is just to look at performing some health checks of the new cell that I deployed, making sure there's no abnormalities or errors. Because if there are, we want to stop and correct those errors before we continue. Now we can see, now I'm actually looking at the NFS server, and we can see that the new cell has populated information into that shared transfer service. That verifies that my NFS mount is working correctly. We have no permissions issues. Okay, I'm going to log into now as root into port 5480 and check PostgreSQL health, and that looked good. Stage 3 is going to be migrating the SQL database. So now we've got two cells, the old, what I'll call the old cell or the existing cell, running side by side with the new vCloud Director appliance. So I'm going to log into or SSH into the both cells. The old cell or the existing cell will be in the upper left corner. The new cell is going to be in the lower right, and we'll do a little bit of work in each of those cells to perform the database migration. So this is the portion where we're going to stop the vCloud Director service or daemon on both cells. Use the same command on both. And now we're going to continue our work in the new cell. Now, according to the instructions, we need to perform or actually create an allow rule on the Postgres database to allow external traffic in the form of the database migration that we're going to perform. We do that by creating this text file, okay? And we provide the IP address and the account and group that we want to have access to the Postgres database on the new cell. I've done that using VI. I've verified with a cat command that that new file and information was populated. What that does in turn is actually populates yet another file under var VMware with that allow rule information. So now that allows us to go back to our old cell, and we're going to perform the database migration. It's you can see the command in there. We're telling the cell to migrate the database using the cell management tool to the new vPostgreSQL database listening on IP address 188.144.114, or sorry, 14. And there's a password in there that I've pixelated out. And this process actually doesn't take very long. It could vary based on the size of the environment, but when it's done, what we're looking for is data by migration succeeded, a success, 0 failures, 0 skips. Again, if you see anything other than that, probably stop, reattempt the migration. So the last stage, or last step, is to migrate the shared data information. So we're going to copy over some files from the old environment to the new environment. And, you know, aside from the SQL database that we just migrated, these, I think it's 5 files. These 5 files hold the configuration of the vCloud Director environment. We're actually going to use these files once we copy them over to perform an unattended or scripted installation of vCloud Director in that new environment. So you can see we've copied over global.properties, response.properties, certificates, proxy certificates, and trust store over to the new cell. Okay. And once we're done with that, these files will be used for that unattended installation. Now, because of the nature and the security implications around using the SCP command, I have to provide the root password for each of the 5 files that I'm copying over. Okay, so this is where we're actually running the unattended installation using those files. This is the opt VMware vCloud Director bin configure command with a whole bunch of switches. And again, the documentation provides those switches, but this imports the remaining configuration data into the new vCloud Director cell appliance. So now we're going to start the vCloud Director service on the new cell. And I'm actually going to tail the cell.log file and watch for any errors or abnormalities here. And once this is 100% completed and we don't see this file continuing to write, that's a good indicator that the cell daemons are now started and we can actually log in with a web browser and perform a quick health check and verify that all of our vApps have been migrated and the health of the database is intact. And we're just about there. And cell startup is complete. Took 59 seconds. It actually takes longer to start up the cell than it does to migrate the data. So now we're going to log in to the provider console of the new cell. I'm going to use the administrator account here, but at this point, my other domain connected accounts should exist because they were copied over as part of the configuration. Now we can see, and there they are. There's the 3 users that I have imported. And we can see I've got it pixelated out, but our license file has been migrated over as well as part of the configuration. And there's our tenant, TechSol, and there are all of our vApps are now populated in the new cell by way of the database migration. And we can look at just another view here in the MyCloud view. See our various vApps and the VMs within those vApps. We've got a couple steps left here. I'm going to take a look at the vCenters here, and you can see that our NSX manager on the right-hand side has been carried over. That's also important for the deployment of VMs. One of the last steps we want to perform is we need to delete the old cloud cell. And that's quite simple. Right-click, choose delete. So now the only cell we have left in there is the single cell of our new deployment. Now we're going to power off the old cell, and we're going to delete it. Remember, we took a snapshot or a backup of this, so if at any point in time something went sideways here, we have a good rollback point and we can fix and reattempt. I've pixelated out some of our VM names here in this environment, but you can see we're looking at VCD cell 2, and we are complete at that point. So I showed all of the steps. I didn't skip anything. I did use time compression on some of them in the interest of time, but following the detailed documentation, It's not a complex procedure. Just make sure you have some form of backup. Use array-based snapshots if you can. I would also recommend using quiescence if you're going to snapshot your SQL database and your cloud cells while they're online. If you do not have the ability to quiesce the data to get app and data consistent snapshots, one method you could do is request an outage from your tenant and shut down both the SQL server and the old cell, and then take a snapshot that way. Then you're sure that we've lost no data in flight, then power them back on. That's the end of the presentation. I'm going to leave you with links to two documentation resources. They both point to the steps required that I followed to perform this migration. One is simply the online documentation on the top. If you prefer reading PDFs or printing out PDFs, there's the vCloud Director 9.7 installation guide on the bottom. Skip right to page 115, and it's really, I think it's about 3 or 4 pages, not even 4, to follow these steps. But you follow these steps and you'll be successful, and you'll have your migration completed. And at this point in time going forward, you will be off SQL Server and you'll be in your new embedded vPostgres SQL environment. Thank you all for joining, and I wish you all a wonderful VMworld.
Hello, my name is Emma Kazmarek. I'm from the Data Protection Division of Dell Technologies. And today I'm going to talk to you guys about how we're providing data protection from the edge, the core, the multi-cloud. So as you look out today at organizations, what we're seeing happening is that they're looking at their data, they're looking at their software, and they realize that within their application as a whole, there's a competitive advantage that they're going to be able to take advantage of. Now, in order to harness this advantage, they're embarking upon these digital transformation, and more importantly, these application transformations are ongoing. And they can't just throw their data out into the public cloud or introduce Kubernetes into their environments and expect that they're going to be able to actually take advantage of this competitive advantage. They're having to take a step back and really do an application rationalization and determine what makes sense to really get the most out of that application transformation. And so as a result of this, what they're doing is they're looking at their applications from a top-down approach, and they're determining, does it make sense to rehost that application? What we used to refer to as lifting and shifting, picking it up from its existing deployment and deploying it in a private or public cloud experience. Does it make more sense to re-platform or containerize that application? Or do we need to just completely rewrite it and refactor it, move it from being, say, a traditional Oracle deployment into, say, a MongoDB instance? Where, you know what, I don't even want to deal with this application anymore. I'm just going to pay somebody else to manage it. I want to move it and repurchase it and go SaaS. Great example of this, getting off of Exchange and moving on to 365 with Microsoft. Now, there are also applications out there that it just doesn't make sense to rehost, replatform, rewrite, or even repurchase. The juice just isn't worth the squeeze. At the end of the day, it's going to be cost prohibitive to even do one of those. And in those instances, we're just going to retain them and keep it business as usual there. Now, across all this, though, if we've rehosted, replatforming, rewritten, or repurchased, what happens to those legacy applications? We have to think about how we're going to retire them. And we may have compliance that requires us to keep them around for 3 years, 4 years, 10 years. And it doesn't make sense to have them living on expensive all-flash storage once we've retired them and moved on to rehosting, replatforming, rewriting, or repurchasing. And so it becomes critical here that we take into consideration data lifecycle management and have the ability to tear it down to the most cost-appropriate storage so we can actually get the biggest TCO and cost reductions out of this. So while this is occurring now from a top-down approach, what we have to take into consideration is the bottom-up and how we support this from an infrastructure perspective. And so when we look at this from an infrastructure lens, on the left side there we have our traditional applications, our physical Windows and Linux, our non-x86 platforms, AIX, Solaris. And then we have everything that we've gone through the process of moving from physical to virtual, from being to being in that virtual environment. And on the left, really, this is a construct methodology. In order to support these applications as they're being onboarded, we're constructing the underlying infrastructure to support them. Now, as we move into the world of infrastructure as a service, containers as a service, or platform as a service, whether this is on-prem in our private cloud or up in the public cloud, more and more, this is in a multi-cloud world. And so in order to support this, this is really a consume methodology here. Now, I like to think of IaaS, PaaS, and PaaS really as terms of a metaphor for a house. In an infrastructure as a service environment, I show up, my foundation's already been poured for me, and I have all my lumber, my drywall, my bricks, my shingles, and I go and build that house. In platform as a service, that house is already built, and I just move right into it. Containers as a service, I have a shell of a house, and every day I'm picking out what the floor plan is going to be, what the colors of the walls are, what the cabinets are going to be, and it's tear up, tear down. And that's how containers had been when they were just stateless. But now what we have happening is organizations are starting to containerize applications, and they're moving from being stateless to becoming stateful. So in that same instance here, I'm picking out the floor plan, colors of the walls, the cabinets, but I now also have a file cabinet in that house. And every day, more and more is growing to that file cabinet. And I need to have the capability of reverting back to 3 days ago, 5 days ago, 2 weeks ago. And I just don't need the status of that file cabinet, but I also need the status of that house. I need both the application consistent and the crash consistent. The challenge is the way that I protect those environments is different than how I go about protecting my infrastructure as a service or platform as a service. And so it makes things very interesting as organizations are going through this transformation on how they're approaching these things. And so when we look at this here, what's important to understand is, where things fall. And in conversations that I'm having with my customers, what I see is that on average today, about 30% of customers' environments fall into that traditional bucket. About 60% fall into that virtual bucket of applications that have gone through the process of being moved from physical to virtual. And then 10% is a scattershot across the board of IaaS, CaaS, PaaS, and SaaS. Really varies from organization to organization where they are on their digital transformation journey. While this is all well and good to look at where organizations are today, we also have to take into consideration where they're going to be in the world of tomorrow. So looking out to the year 2023, what we see is an interesting shift in these workloads. What we find is the traditional applications are only going from 30% down to 20%. And at first, that kind of makes you scratch your head, but when you double click on it, it actually makes a lot of sense. And the reason for this can really be compared back to the whole mainframe conundrum from the early 2000s. Mainframe was supposed to die in the early 2000s, yet here we are 2 decades later, and the majority of Fortune 100 customers are still running mainframe in their environments. The same is true for these traditional applications. These are the cornerstone applications that have been ingrained in environments for years, non-x86 platforms, things that are very difficult to try and rehost, replatform, rewrite, or even repurchase. They've been so customized, and they continue to do very important aspects on the environment, and trying to get off them is near impossible. But where we really see this shift into the consume methodology is on the virtual workloads, going from 60% down to 10%. And really, this is being driven by 2 key things. The first is automation and the ability to take these workloads and automate them into those consume environments. And the second is really being driven by VMware as a whole here, with their ability now to deploy Kubernetes services within their private cloud environments, is really allowing organizations to streamline their adoption and drive their digital transformation forward. Now, when we look at this from a data protection lens, it's important to understand how all these different components need to be protected. From that traditional side of the house, we know how to protect those environments, right? For your physical servers, you're going to put an agent or a client out on them. You'll have your backup server, your media server, and you're going to write it to a target. When it comes to those virtual workloads, we should be using VADP, the VMware API for data protection. We should be doing image level backups. We don't want to be having a bunch of guest clients out there that we want to be managing across the board for hundreds and thousands of VMs. Maybe we're also going to be leveraging some proxies to accelerate that data transfer. but again, it's landing on a target. Now, as we move into the world of consume, whether I'm deploying a virtual machine, an application, or a container, I need some sort of portal for my end users to interface with to drive this model out there. And 9 times out of 10, what I end up seeing is that portal ends up being ServiceNow. But ServiceNow on its own is really just a ticketing system. I still need some automation tools underneath there to drive the deployment of these production VMs, applications, or containers. And so the market leading vendor out there from an IT automation tool set is VMware. So having native plugins into the VMware automation tool suite becomes critical. But it's also important to understand that as part of organizations' digital transformation, they may be leveraging additional automation tools. They may be using things like Ansible, Puppet, Salt, Terraform, Otter, or whatever the next one is that hits the market. So it becomes critical that not only do you have native plugins into the market-leading automation tool set, but that you also have open REST API capabilities so that you can integrate in those automation tools into your data protection solution as you go through your transformation, so that you can integrate into the Ansibles, the Puppets, the Chefs, what have you, and have that flexibility and choice. Because the last thing that you want to do is stand up your entire automation deployment for your production environment, but then still have to manually touch it from a data protection side. It's counterintuitive. As your production workflows are being deployed, the protection capabilities should flow with them as well. Now, once I get to this point and I've stood up this framework, I've got to answer 5 key questions. And based on the answers to these 5 key questions, is going to determine where this data is going to live. And that comes down to cost, availability, performance, location, and compliance. Based on the answers to those 5 things, the data is either going to go one of 2 places. It's either going on-prem or it's going off-prem. It's going off-prem, it's going into AWS, it's going into Azure, it's going into GCP, or it's going into VMware Cloud on AWS. If it's going on-prem, it's being deployed as a converged or a hyper-converged instance, or as a software-defined solution on the hardware of your choice in your private cloud environment. Now, we still can't forget, though, about those applications that we've decided to outsource and repurchase. You know, we may have more compliance requirements for those resources than what those vendors are providing. Some of those vendors may not be providing any protection capabilities at all. So we have to make sure as we go down the path of repurchasing applications and moving those into SaaS models that we have the ability to protect them that meets the internal compliance requirements of our organization as a whole. Now, when we get to this point, we see a need still for 3 key things. The first is integration with object storage. Going back to the beginning here in that application transformation that's occurring, for those applications that we've retired, the ability to integrate in with object storage becomes critical, and having the ability to tier that down to the object storage of choice based upon policies of age becomes critical, so that we no longer have to maintain them living on expensive all-flash storage. But in addition to this, being able to leverage our market-leading IP and data reduction ratios to shrink that actual physical space that it's consuming upon allows us to bring forward the most efficient TCO out there and cost reduction ROI for our customers. And it's not just about integrating into one object storage platform. While we prefer it to be ECS, we understand that as part of your transformation journey, you need to have choice and flexibility. So being able to integrate into the object storage platform of your choice, whether that's S3 infrequent access, Azure cold blob storage, or even Alibaba Cloud, allowing for that flexibility of that journey. We also see a need for object store integration as we start protecting workloads in the public cloud. The last thing that we want is for the most expensive thing in the public cloud to be your protection solution. That's why our technology, when we protect workloads in the public cloud, leverages that cloud native object storage as its consumption of what it's running on and writing towards, enabling our customers to continue to drive down costs and have that cost reduction, allowing them to be investing in things that are actually important to them in the public cloud, things like microservices, things like database as a service, those really things that are driving that transformation forward so that we can keep them protected, but drive down costs as a whole. The other key area that we see a need for is the ability to provide an air-gap copy of the data for those mission-critical crown jewel applications. And where those crown jewel applications are going to shift depending on where organizations are throughout this journey. So the ability to vault down those applications, whether they are deployed as traditional, and whether they are deployed in your private cloud, or vault them down from the public cloud, becomes paramount, so that you're not in a position where you have to end up spending or paying Bitcoins to the bad guys to get your data back. And on top of this, it's about not just allowing for that, the ability to protect those critical applications, but also those critical rebuild materials. So, because if you're in a DR scenario, you're assuming that you've got access to the DR site, that you've got asynchronous replication, that you can come back up. In a cyber event, you need to be assuming that you are coming back from nothing. You're having to recover from bare metal. And so you need to make sure that you have those critical rebuild materials, things like Active Directory, things like domain controllers, things like networking templates, so that you can actually bring back those crown jewel applications holistically in your environment. And the final key piece here that we see a need for is the ability to provide one common management plane. Whether you're protecting traditional or virtual resources in your construct environment, or protecting workloads up in the public cloud, having one common management plane that gives you visibility across the board so that you are able to have reporting and management through that common pane of glass. Because while we may have automated the ability to protect workloads in your consume environment, we still need to make sure that we're taking into consideration how we are protecting those 30% of workloads down the road that it will continue to be in that construct environment. And having that one common management plane that's built on HTML5 is something that we're providing for customers today. So when you look at our portfolio, this is really what we're focusing in on for our customers and what we're delivering on for them across the board. And this is really kind of specifically due to our focus and our strategy as a whole. And when you look at this, we're focusing in on the mega trends of the industry, providing value to the data that we're protecting applications as they're going through this transformation. And as data now has been distributed to the edge more than it ever has in the past due to things of work from home in the current times we're living in, it becomes critical for us to be able to provide our abilities of leveraging AI and machine learning to look in at the entropy of the files themselves, to identify if the change rate has gone from an average of 3% over the past 18 months up to 98%, to make sure that the file type still matches the extension, and to identify attack vectors that we see that are common in environments to address them. And we're doing this by continuing to provide that proven technology and leadership that we have in the industry around simplicity and automation, efficiency from a protection standpoint, and driving efficiencies in customers' environments, being able to provide protection at scale, and being able to provide that protection performance as customers continue to drive, while also focusing in on delivering modern innovation, being able to provide that native cloud protection, autonomous protection for applications as they move from the edge to the core to the cloud, and also being able to introduce new services and recovery options for our customers as they move forward. That's what we're doing here at Dell Technologies, and that's how we're providing protection for our customers from the edge to the core to the cloud. Thank you, and have a great day.
Hello, everybody. My name is David Klebanov. I'm with a company called Alkira. And today we're going to talk about a pretty exciting topic. We're going to talk about networking. Like, when was the last time that networking was exciting, right? So, but today we're going to make it exciting. And what we're going to do, we're going to talk about networking, not just networking in general, but we're going to focus on networking in the context of a cloud. Like, what does happen to networking when the cloud era hits? And specifically, our agenda is going to be around three individual topics. We're going to recap the different options that exist today for cloud networking. We're going to talk about what are the challenges around cloud networking today, how are these challenges being mitigated. So spend some time talking about that, but then really talk about the Alkira solution and see what we bring to the market with what we call an Alkira Cloud Services Exchange, which is really focused on solving this networking and other issues for the cloud era. And at the end, I'm going to give you a bit of a glimpse on a couple of deployment use cases or main deployment use cases that that this technology can be applied to. So let's play out an interesting scenario in here. So think about this three personas that you see on the bottom of the screen. And in fact, these are the two categories of personas. The first category of the persona is the networking and security person, right? This is the traditional infrastructure, IT personnel dealing with all the networking and security aspects of the infrastructure. And then next to it, you have the cloud architects, the cloud administrators, and the application developers. So these are the folks who are dealing with directly with the cloud aspects of it, from the compute standpoint, from the storage standpoint, from the application standpoint. And now look at the collection of these clouds, right? Now, some of these clouds are familiar to us as an infrastructure as a service clouds, which are the three main ones for AWS, Microsoft Azure, and Google Cloud Platform, the GCP, right? But we also have the SaaS offerings, and there's quite a few applications that really kind of a part of that software as a service offering. But some of the most prominent ones are Office 365, Salesforce, Box, Dropbox, all kind of software as a service applications. And then, of course, we have the internet applications, which are more of a generic in nature. So when we see, from the persona standpoint, when we see the cloud folks, how do they perceive these clouds? They're really enjoying the day, right? These clouds were built for compute, storage, application, microservices in mind, and really cater to the needs of the cloud folks. And if you think about some of the key attributes that are really playing very well in that space, are the time to service, the agility around time to service, the ability to do on-demand capability delivery, right? The as-a-service consumption, which is extremely important element that we're going to come back and circle to a couple of times. And then the ability to do scale up and scale down for the infrastructure. Now, these are all great. At the same time, when you look at what happens to the network and security aspects when it pertains to the cloud, you can see the plethora of challenges that network and security architects and engineers are facing around scalability and the expertise that are required, and security and visibility and over provisioning. So quite a few challenges that these folks are facing. So how is the industry coping with this? What are the several sort of solutions that exist on the market today that allow the networking folks and the security folks to try and address the networking needs for the cloud? So the first one that we're seeing quite a lot is the use of the co-locations, right? It's a very proven, very solid model. However, it comes with certain drawbacks. Many times co-location deployments carry a high provisioning cost, right? A complexity of provisioning, because many times they are anchored on a physically deployed gear, physically deployed equipment, right? Routing between different regions of the same cloud or across multiple clouds becomes very cumbersome, because the traffic needs to be extracted from the cloud to swing through the co-locations, especially if network services such as firewalls are deployed in those locations. So the suboptimality of routing is something that strikes the tone with the co-locations. The second approach that we're seeing is a cloud-native approach, where organizations are leveraging the cloud-native capabilities of the three major clouds, the AWS, Azure, and GCP, in order to deliver these networking capabilities. So some of the drawbacks we're seeing is that it's really dependent on the cloud provider. Every cloud provider addresses this differently. So every solution that is built on top of these clouds in a cloud-native fashion is very specifically tailored for that cloud. Lack of expertise from the networking and security folks becomes very, very challenging, because again, the clouds have been built with compute, storage, application in mind, not quite with networking and enterprise-grade networking in mind. And when you figure this all out and you somehow deploy this, you are hitting quite a lot of restrictive cloud limits, especially for networking and security, because these clouds were really not, like I said, were not envisioned to be built with networking, security, visibility, and other elements inside. Now, the third one that we're seeing is the do-it-yourself approach to cloud networking. This is where the organizations are leveraging either automation, orchestration, or provisioning tools in order to automate some of those tasks that would otherwise be done in sort of mundane manual fashion, doing this using this automation, orchestration, provisioning tools, still in a do-it-yourself fashion, but a little bit more sort of elegant. Now, those are obviously provide an evolution over the previous methods, but yet they also carry a certain degree of suboptimality regarding learning curve around those tools, the disruptive nature of deploying those solutions because of the need to download software into your existing cloud environments, and to some degree, a large failure domains that are created by the fact that these do-it-yourself networks really span multiple clouds without any means to constrain problems, routing-related problems that could arise from human errors, misconfigurations, or things like that. So when we think why these problems exist, the thing that really strikes the tone is that the cloud and the network really operate based on different characteristics. When you look at the clouds, you really see the clouds operating on the level of principles, on the intent-based approach, while the network is operating on the level of primitives, which is really understanding these nitty-gritty details and all of these nut and bolts that need to be sort of operated in order to build the network solution for the cloud. Now, where we really want to transition is really want to bring the network philosophy and the way of thinking closer to the way the clouds operate. And by doing that, we really empower the network to behave like the cloud and have those cloud-like attributes. And that is going to create this cohesiveness between the cloud and the network, and is going to allow the network to really deliver on the cloud promise. Now, let's look really quick on the Alkira offering in this space and how we are mitigating some of these shortcomings that we talked about prior to that. So the service that we are offering is called an Alkira Cloud Services Exchange. It's a solution. It's anchored on what we call an Alkira Unified Network Platform, which is a foundation for an entire solution. It comprises of a collection of what we call an Alkira Cloud Exchange points, which are, think about those as a virtualized cloud, multi-cloud points of presence. These are not hardware-based. These are not VNFs. This is a completely autonomous software stack that is deployed on top of the hyperscale infrastructure and really allows the organizations to bring the resources, be those single cloud resources, multi-cloud resources, on-premise resources, users, SD-WAN fabrics, whatever lives on-prem, into this unified network platform through the connectivity through this Alkira Cloud Exchange points. Now, if we think about some of the key attributes that come with that type of approach, is an ability to completely design your network using a digital design canvas. Basically, draw your network on the design canvas to express your intent, and then click a button to implement or provision that intent onto the actual virtual infrastructure. The ability to insert network services such as firewalls, load balancers, DNS, DHCP, IP address management systems, and others into this network, leveraging this digital design canvas, and then using the intent-based policies in order to steer the traffic. Now, the elements around segmentation, encryption, which are the security aspects, the day-to operations around visibility and governance for this network. And again, at the end is the chargeback billing elements of the solution in order to really kind of have a deep understanding of what are the resources that are being consumed, and pay only for the resources that are being consumed as part of the solution. Now, the three really key things that I wanted to kind of leave you with in this slide is a delivery of this entire solution as a service, which is a very sort of significant contrast to the do-it-yourself approach that we talked about previously. The ability to provision everything in a single click using the digital design canvas and the integrated network services marketplace, and the ability for this entire intent to be provisioned on top of the infrastructure and really be ready for use in minutes. So these are the three things I really wanted you to leave with this, from the understanding of the solution. Now, let's quickly look at three popular use cases that we're seeing being deployed out there. The first one is pure networking use case, right? And you can think about this as an end-to-end cloud or multi-cloud networking use case where you have multitude of cloud workloads from various clouds that are being connected into this cohesive network infrastructure, right? So we're talking about multi-region or multi-cloud in some cases, multi-account in cases where you have different departments that are leveraging different sort of credentials to access their workloads. So all of that is being cohesively brought into the Cloud Services Exchange solution. The ability to provide an end-to-end segmentation across these multiple workloads and micro-segmentation to sub-segment certain workloads within a segment, right? The ability to do a global route propagation within this segment, so keeping the segmentation end-to-end, yet providing the global route distribution and route propagation across the regions, across the clouds, be that within a single cloud exchange point or be that across multiple cloud exchange point really on a global scale. Now, the sizing of those cloud resources and the ability of the network to really accommodate the sizing of these workloads as required. So when sort of a compute administrator deploys a workload that requires large or extra large capacity, a network can play along with it and provide the connectivity that accommodates those needs from the compute standpoint. And as I mentioned earlier, the ability to really just pay for the services that are being consumed in form of billing or perform a chargeback to the organizational units that are consuming those resources. So IT does not really become a single bearer of the financial responsibility for the deployed solution. The second use case that we're seeing a lot is the use case around stateful security. So as these applications move into the clouds, we're really seeing the need for the security to be extended into the clouds and really maintain the same security posture that existed for these applications where they were on-prem, and maintain this posture when now these applications reside in the cloud. Now, I'm giving here an example of the Palo Alto Networks firewall, right, and how firewalls being deployed within the Alkira Cloud Services Exchange with auto-scalability to accommodate an increased and shrinking demand for capacity, and the ability to do firewall zoning in order to segregate different resources, be those an on-prem resources, sites, users, SD-WAN fabrics or whatnot, cloud resources, AWS, Azure, GCP, but also an external resources such as extranet connectivity through mergers and acquisitions, partners, or just a plain internet-based resources. And all of these are just mapping into this zone-based approach inside these firewalls that are deployed within the Cloud Services Exchange. So really the ability to bring that stateful security from not just an on-prem data center applications, but all the way into the cloud applications. And lastly is the use case around operational visibility for network and security. Now, obviously, when you deploy networks, you have to make sure that operational elements, visibility elements are accommodated. And here, there's a really multitude of different visibility, troubleshooting, health, visibility elements around networking, security, and the entire operations of the environment. Now, I know this was quick, just to give you guys a bit of a sample of what we do and how we solve these cloud networking challenges. If you want to learn more, we invite you to go to www.alkira.com, watch videos, read briefs, schedule demos, and take the next step in that networking journey for the cloud. With that, I wanted to thank you and wish everybody a pleasant day.
Hi everyone, my name's Dean Lewis, I'm Technical Account Manager at VMware, and today we're going to be talking about the VMware Folding at Home appliance and our efforts to support the Folding at Home project. Just a little bit of background about myself. Of course, my career focus has been in virtualization, as you can imagine, working for VMware. Outside of work, I'm a keen scuba diver, and you can get in touch with me either through my blog, theeducate.co.uk, or on Twitter at SaintDLE. High level, we're going to be covering what the project is, what is protein folding, what are the outputs from the project, how to get involved, and then, of course, a little bit of a technical demo as well. So the Folding at Home project is a distributed computing software project for simulating protein dynamics, which we'll talk about a little bit more in a moment. brings together volunteers from around the world to run the simulation of protein dynamics using their own personal equipment, their home labs, or in the case of, where possible, on their business equipment as well, as long as their employer allows them to do so. The insights from this data help scientists to understand the biology better, viruses and diseases, and provide new opportunities for therapeutics. The project itself was founded in October 2000, and on March 20th of this year, VMware released the VMware appliance for folding at home to help support the project's efforts for those with vSphere environments. And first and foremost, I'd just like to start with a 60-second clip from our CEO, Pat Gelsinger, about our efforts to support the project.
Hi there, Pat Gelsinger here. I'm a firm believer that technology can and should play an important role in medical research, especially for fighting the COVID-19 pandemic. It's why folding at home is so exciting. In a grassroots example of our commitment to citizen philanthropy, over 1,000 VMware employees, partners, and customers joined Team VMware Folding through the globe. A few of our employees have gone above and beyond through our VMware Foundation's Good Gig program to strengthen the Folding at Home project by assisting in modernizing applications and creating a secure multi-cloud strategy. I'm so proud of the VMware community for coming together to take action for what they are passionate about. And thanks to everyone around the world who has been involved in this program by sharing your unused computing power. It's truly amazing to see such an outpouring of support. You can learn more at foldingathome.org. Thank you so much.
Okay, just to give you a little bit of context, VMware's ethos, as Pat mentioned, throughout the company is to produce technology for good. And for me, getting involved with the Folding at Home project is a really simple way to help contribute in the fight against not only COVID-19, which of course is affecting us all today, but other diseases such as Alzheimer's. We obviously believe that our individual actions add up to our collective impact. And as you probably heard the saying, big things have small beginnings. The VMware Folding at Home appliance is really kind of encapsulates that quite well. It was a concept to a public fling in 72 hours, and that's our fastest release ever. So digging down into the scientific side a little bit, what is protein folding? A protein itself is the basis of how biology gets things done in the human body. As enzymes, they help drive our bodies, build structural elements such as bones, muscles, skin, and blood vessels, antibodies, which allow the immune system to get rid of unwanted invaders. What is folding exactly? So a protein takes a shape called a fold in the body. The image in front of you, we have the image of a folded protein on the right-hand side. And the Folding at Home project is looking for gaps whereby drugs can bind to a protein to help the body in its immune response and to fight diseases. It's very similar to putting the pieces of a very complex jigsaw together. And what are the outputs from the project? Today, there's already a number of papers which have been released from the research conducted by the project and the researchers that are involved. And these images in front of you, we're looking at the same protein whereby distributed computing scale of the project has allowed researchers to understand how this virus binds to our cells. For those of you who are fans of Stranger Things, this spike has been nicknamed the Demogorgon. And the researchers' aim now with this spike is to understand which drugs are available or can be created in the future which attack or bind to the opening of the mouth, the Demogorgon, to stop it from binding to our human cells. Just finish off with some statistics. So Folding at Home does offer a little bit of gamification for those of you that are competitive out there. We've roughly at Team VMware contributing to the project just have over 1,000 active members today, and hopefully by the end of this presentation we'll add a few more. We produce the fling to help volunteers easily get started to contribute their resources from their vSphere platforms, and currently we have around 42,000 downloads of the fling. We can also call on our vendors and maybe even our competitors in Dell, Nutanix, Rubrik, Easty, Veeam, SunGuard AS, and many others, such as VMware partners and customers using our fling today to contribute to our team or their own teams as well. And we're going to discuss about how you can also join our team and contribute. One of the questions that I'd like to ask if you want to get in touch with me directly is, how many of you today are using our Fling? And as you can see in this big column here, a lot of users that downloaded our Fling originally downloaded the original version, but never moved or downloaded to a newer version of the Fling itself. So again, there are some benefits and features and reasons to do that. If you're unsure, then please, at the end of the session, reach out to me as well, and we can chat about that too. As Pat mentioned, getting started is really easy. Just go to the foldingathome.org website. You can either start folding locally on your machine, which we'll cover in a second, or the more technical demo is going to be looking at running it on a vSphere platform. Running it on your local machine, as you'll see in a second, we just kind of access this through a local hosted website, and it just runs in the background as we need. Or we have that more in-depth OVA, and we'll also talk through some options available for managing this at scale. So I'm going to move into my lab environment now. So as mentioned, going to the website is going to show you the version for the operating system that you've loaded from, and you can see the vSphere environment as well. And I'm just going to click on the alternative downloads, and we'll come back to that in a few moments. Running on my local machine here, so this Windows server has the Folding at Home software installed. Today, I don't really need to show you how to install an executable. We're all okay with that. But what you will be able to do is add an identity, link yourself to a team. You'll get some statistics that come through to help with the gamification side of things. You'll also get some really cool information, such as which project you're contributing your CPU cycles to. And the numbers displayed here really just kind of summarize the shard or the part of the protein that you're going to compute against as well. Proteins, we mentioned before, very complex items. You need a lot of CPU resources to compute those folds. So you will find that you will not get a single project item to yourself that is looking at the full protein itself. You're always going to get a small part of that. On our flings.vmware.com website, you'll be able to find the actual appliance for folding at home itself. We've got a number of requirements listed. You can essentially run it on pretty much any version of vSphere that's supported today, or VMware Fusion or Workstation. We've got the OVA to download, full in-depth deployment steps, an FAQ as well for commonly asked questions, and if you want to go a little bit more advanced, we also have instructions on how to use a GPU as well. So I'm going to take you through a quick demo showing you how to deploy the OVA. It is pretty simple, to be fair. I've already loaded up the OVA from the Flings website just to save some time. We're going to deploy that virtual machine. So we'll give it the name of vBrownBag -FAH. We can select an area to deploy it to. And realistically, none of these options for deploying an OVA different to what you've been used to in the past. Just take a couple of moments to validate. And the first decision you need to make is the size of the OVA itself. So we've given you some basic guidance on what we found works really well with the appliance itself. And as I mentioned, the software is very CPU heavy. So you start off with 2 CPUs, 1 gig of RAM. A large machine is going to be 16 CPUs, 4 gig of RAM, but you can change the OVA appliance manually yourself after you've deployed it. 4 gig of RAM is the maximum you need for the virtual machine, but you've put as many cores as you've got available to that appliance. Then select your location to deploy to, your network, and then you've got the OVA appliance settings itself. So we're going to provide the host name, IP address, gateway, DNS, the typical settings you expect for a Linux appliance. If you leave these blank, that's perfectly fine. We'll use the HCP for networking. We've got proxy settings if you go through a web server for whatever reason. Then we've got some mandatory settings. You're going to have to set this root password. If you do not set that root password, when the appliance boots and tries to auto-configure itself, it will fail. And you'll actually see a little login screen that says vghetto-login. Setting the root password then will actually show the host name that's set for the OVA once it's deployed and the first boot has completed. So I'm just going to set VMware1 exclamation mark for this demo. I'm going to enable SSH so I can get to this machine remotely. I can set the parameters for the Folding at Home software itself and link to my user account. We do recommend using a passkey. It's just an additional way to authenticate yourself. It's a unique key to yourself. But again, you don't need to set any of these options if you want. You can just contribute to the project anonymously. Set the mode in terms of how many cores of the virtual machine it's going to use. Because it's dedicated to OVA, I always recommend full. If you want to use GPU enablement, then you're going to have to enable it here. Set which networks can access the OVA appliance itself. And also set a remote access password as well. We also have the ability to show a top console for the OVA once it's deployed to see your environment. And then finally at the bottom, we've got some advanced settings around debugging and next unit percentage. Again, I encourage you to kind of read some of the documentation at home about what these settings do. Okay, so I've already deployed some virtual machines in my environment to save some time. And I'm just going to show you a virtual machine that's been deployed straight away. So in the web console, by default, we've got this top environment. I can see how many cores are being used. And at the bottom there, we're tailing the logs of the software. And we can see that I've computed 99% of this particular work unit that's been downloaded by the FAH client. One of the things I also want to show as well is we have the ability to download an FAH control software when you've deployed many appliances. If you download the Windows or Mac OS X client to run it locally as well, this software is included. If you're running on Linux, it is a separate download. Once installed, you just look for FAH control on your machine. It's a very, very simple interface. You will go in and add your client machine and the host, the IP addresses that it's booted on, or static IP address you've given, the port that you are interested in. So by default, this is, we use the default ports, there's no change there. Password displayed for the OVA deployment itself. And then your interface will look like this. We've got the same settings you actually see through that web interface, such as the project number and IDs we're working on. And if I open up the advanced settings, again, we can change the identity. So if you get something wrong, you can change it. The slots, this will be set for CPU by default. You're going to have to configure some of these extra settings yourself for GPUs. We've got the remote access settings, got proxy settings, some advanced, and we can even select which cores we want to dedicate to. I just choose for any disease that's available for any project. And then finally, expert settings as well. So we won't in this particular call go through them in much detail, but we do have some answers in our Folding at Home FAQ on the Fling website for you as well. So I've really taken you through a whistle-stop tour of how to deploy the OVA and how to manage multiple OVAs itself. Everything else, you leave the software to itself. One of the things that I'd really like to call out, just by going back to the slide deck in my last 60 seconds here, is once you've deployed the OVA, sometimes you'll see that you get failed to connect messages in the logs, and this is fine. The Folding at Home environments have hundreds of thousands of users and millions of users during the COVID at the moment. And sometimes the work servers that we download the researchers' projects from and also upload the completed work units to can come overloaded. The software itself is designed to work in the background to continue to try and upload those files and download new work units as well. So I really recommend that if you're seeing this error message, don't panic, leave your software to continue running in the background. If you realize, that it's maybe going on for a number of hours or even days where you're getting nothing, then please reach out directly to myself over Twitter or through my blog, through the Fling's website as an issue, or go to the Folding at Home forums as well for additional support. I'd really like to wrap it up there today with a final call to action. It's very easy to get started. Just go to foldingathome.org. And I've also just like to end on some short links as well so that you can go directly to our Fling website and also to the blog covering the common FAQ. Thank you very much for your time in listening to me today. It's been a pleasure.
Hello, and welcome to the session about bootstrapping VMware, the infrastructure as code way. What we're talking about in this session is BYO infrastructure. It's an approach to automating VMware at the bare metal level and then upwards. I'm Rob Hirschfeld, your guide for this session. I'm co-founder and CEO of RackN, and I've been doing data center automation and VMware data center automation for over 20 years, believe it or not. You can find me online. I'm at Zehicle, and I've been very active with something called the 2030.cloud, where we talk about a lot of advanced futuristic concepts in DevOps. And so what we really want to talk about here in an infrastructure as code sense is to look at this traditional infrastructure stack that we've built. Because we know that if we fix things at the bottom, that physical layer, then everything we build on top of it, and this is a totally standard VMware infrastructure stack. It's something you would see in other vBrownBag presentations. As a matter of fact, it's modeled on them. So what we've seen is that while people like to squeeze the physical layer at the bottom of this down into this tiny part of the stack, it's actually a complete stack in itself. It's not just a small box. It's actually compute, storage, and networking components that you have to get right, and actually very carefully right, in order to make everything we build on top of it work. And so at RackN, we spend a lot of time thinking about exactly this problem and how do we treat these components like a cloud. And a lot of what that means is, how do we take DevOps automation pieces, infrastructure as code concepts, and automate that physical layer also? Because if we can do that and use the tools and techniques and all the great cloud-like style, we can really make a huge difference in what it's like to actually run a data center, really transform it in very positive ways. And that's what we want to talk about. It's worth mentioning RackN Digital Rebar is this product that we have that's designed to help companies self-manage VMware. So we're not a consultancy, we're not a service provider. We're literally helping companies manage their own VMware infrastructure, whether it's legacy, new, or edge infrastructure. And so that's really about automating infrastructure, securing it, and making it portable so that you get reuse out of the problem. So we see this quite a bit. We're helping multinational customers and service providers automate VMware and do it themselves. So we have a lot of experience with this. And what we've learned in this is that there are really 6 key factors in design that you need to understand before you even write a line of code or a line of infrastructure as code in this case. And so in those factors, we have an organizational component where you really have to be able to say self-management is possible. I can do this myself. I don't have to turn it over to a VxRail or an HCI vendor or a cloud, that you can actually do it, right? And believe that you can do it. To do that well, you have to have human understandable operations. So people have to be able to see what's going on as we automate it. And then once you've done that, it has to be continuously repeatable. We don't look at infrastructure as code and think that it's a one and done thing. You have to be able to keep redoing this. One of our customers calls this repaving their data center. And they literally roll through upgrades and patches in a 30-minute window, and they repave entire 100 system VMware clusters in that time window. And that is how they create these repeatable, robust data center infrastructures, by being able to just click a button and rebuild everything in their data center. And then on the technology side, we also have to approach infrastructure as code in a systems way. So when we look at this, we're not just trying to solve one problem. Can I provision a machine or can I configure it? We're actually connecting a whole bunch of pieces together, from certificate management and inventories and manifests and DNS. All has to be done together. Otherwise, we're really just creating little islands of automation. To make all this stuff work, it has to be observable. So black box things where something happens by magic do not create reliable infrastructure as code things. Any place where you're pointing to a black box and saying Darby Dragons, you're going to have a problem with your automation and in your code. And that's a lot of what we're trying to do, is take everything that we do from an automation perspective and put it in a code repo. And then we're creating Nether into deploying VMware. From there you have cloud or physical through this and understand what the machine is. And then we'll install VIBs in an automated way. You can't create an island where ESX requires its own automation or its own manual steps. What you really need to do is come back and have a way to complete the ESXi infrastructure correctly to do it. And our VIBs are actually signed, so we can do this all with something else. That's where we now have enough information that however you want to automate on top of that, you have the information that you need, whether it's Ansible or Terraform or whatever mechanisms, or if you're back into CSV spreadsheet land, you have the data that you need to make that all work together. And that's really where we start pulling together these infrastructure as code concepts, because everything I'm showing you in this list are all components and modules that fit together. It's not a big bash script or an Ansible playbook that works, if you put in a whole bunch of value, it's actually things that you plug servers in and just the right things have to happen. And that's what makes infrastructure as code really interesting. And it's not just another HCI story where buy this exact hardware, put things together in exactly the right way. People's data centers are different. And for good reasons, they're different. And so we have to be able to accommodate those differences and let people bring in their own infrastructure and their own legacy infrastructure. And as we go migrations from 6 to 7, you have to be able to take what you have. You shouldn't have to buy completely new infrastructure. And so here's what we hear for customers talking about their needs from infrastructure as code. They need to have useful abstractions. And we're going to go through each one of these, and I'll show you an example of how that looks, and orchestration. But at the end of the day, what we're really doing is working to eliminate manual steps and silos. It really is that simple. That's the goal for infrastructure as code. So when we look at modularity, the idea here is that we're not just looking at a single script. What we're looking at doing is taking big problems, how do we automate a system start to finish, breaking it down into small pieces and making sure that each one is modular and then ultimately understandable. And that lets us build a catalog where things that aren't VMware specific or Linux specific or Windows specific can actually be downloaded and reused, right? RAID and BIOS configuration, while tricky and finicky, is not unique. No customer has unique BIOS configuration. They might have different settings, but the process and the way you do that is something that we can standardize and we can pull in and get code reuse from. And that's really important. And then really importantly to us is if you change it and you extend it or you add to it or you add your own magic sauce, which everybody has, then you have a way to code that, manage it, create your own catalog. Because infrastructure is code, the as code part, a lot of that comes from how you store it and manage it and version control it. All super important. And then from there, you have to be able to understand how these pieces work. And that means that these big modules don't just break down into big modules. They actually have to have clean and understandable inputs and outputs with good documentation and types and clear delineations. And then the big steps have to break down into smaller steps that you can understand. And that can go for us, it goes from workflows into stages into tasks. Tasks actually can decompose into templates because we want to get reuse. And that means that if we solve a problem once, we want to be able to rebuild new modules, click things together in ways that actually create reusable pieces. And that is really helpful because when you're building an infrastructure start to finish like this, we're crossing teams. There's a human element component to how all this stuff works. And so that means that we have to be able to show another team what we've done in a clear, concise way. And then we have to have a handoff so another team can do that work. And that's okay. They have clear inputs and outputs. They put their pieces together, and then we fit everything together into a simple workflow. And that's really a key component for this because it's not just about, can I provision a machine? It's, can I build a cluster? Can I build clusters and more clusters? Can I go to remote sites? And so there's a concept of building workflows that actually go through and pull all these pieces, these infrastructure of code pieces together. So if you have a Terraform template and an Ansible playbook and a bash script and a pull this ticket and this person has to go turn on a network port, that's not really an infrastructure as code workflow. It's a collection of tools, but they're not built together to deliver a consistent long-term deliverable. That's really what we're talking about, what we would call intent-driven infrastructure. I need you to build a cluster, start this process, everything else should be able to flow out of that. And then from that perspective, that sounds very cloud native, it is. And it's this way of thinking about API-driven infrastructure where you're asking for a request and things are getting done for you. In a lot of cases, we don't expect people to use our system directly or sit in the UX, right? This should be, I need to build a cluster. That should be triggered by external events or other systems or things up stack from where we are. That API-driven mentality is essential to building good infrastructure as code. Once again, it's all codified infrastructure. Those APIs become the gateway between different systems and help you connect all these pieces together. And then finally, one of the most head-shaping things that we've had to learn in this is that building infrastructure of code means that you have to cross context boundaries. So in the work that we're doing and the thing that we found to be really powerful in making it all come together is this idea that I can bounce my context back and forth. I can do work in a machine. I can pull up to a cluster level, verify that things are right, return back to the machine. And this ability to move back and forth from a context perspective really changes the game in how you can automate something, because you can build a single workflow that has different security contexts, collects information, can work across the cluster, and coordinate activities in a way that is absolutely essential to accomplish this end-to-end system driving perspective. So I hope this helps you understand how we see infrastructure as code and really where the industry is going, because this isn't pie in the sky things. This is actual work that's being done by customers in the field. They're using these techniques. They're actually building data centers and clusters based on infrastructure as code practices that are repeatable, safe, and secure. Whether it's a brownfield system, it's a greenfield system where they're bringing in new ideas and new capabilities, and then being confident that the things they've done aren't going to be locked in for the next 10 years, and they'll be able to change and keep revisiting how things go. If this is exciting and interesting, please, we'd love to have an extended conversation with you at rackn.com. And everything I'm talking about, we have people doing. You can try yourself. You can just download Digital Rebar, try the VMware pieces, build your own clusters. The stuff we're doing is really designed to be that simple, because we're helping people self-manage their infrastructure, not take over control from them. So, thank you for spending a couple minutes with me learning about infrastructure as code. This is Rob Hirschfeld from rackn.
Hi there, my name is Chris Noon, and today we're going to talk about how to automate NSXT using Terraform. So my Twitter handle is alttransformer in case you want to reach out to me or follow me after this presentation. And I do blog on vmusketeers.com. So first of all, let's talk about what Terraform actually is. And it is infrastructure as a code created by HashiCorp. And what it does essentially is automate infrastructure and or network builds. And it does this in a declarative manner. So what we talk about there is we give Terraform a bunch of files and we say, this is the end result I want, rather than building out a system systematically. You can link this with a version control system. For example, I use GitHub, so you can roll back to any previous version that you have or branch out to test new features. And essentially, if you end up playing with Terraform, you'll end up having a bunch of providers, modules, and Terraform files in your file structure. So the use cases of Terraforms are vast, but the ones we want to focus on tonight are the disposable environments. So when we talk about a disposable environment, we're talking about things. Maybe we want Monday to Friday, 9 to 5, and then we can tear them down when we want. Resourcing schedulers are kind of tightly coupled with that, so we can scale up and scale down using Terraform. Multi-cloud deployment is also a really useful use case. So we can use the same code to deploy in GCP, Azure, and AWS. So you can have that multi-cloud environment. Auditing is also a great feature. So what we do at the end of the live demo is we do a Terraform show command. And what that does is it just shows you the environment that we built out in semi-readable code. So we haven't got a lot of time, so I want to jump into the live demo fairly quickly. But essentially what we're going to build out today is a production and a development environment. We're going to build a web app and DB segment in each environment. What I'll do is I'll start by building out the segments. I'll then add the T0s into that. Then I'll link them together. The demo is quite simple in the fact that it's only 3 segments linking to one T0 each. But what I want to point out is you can make this as complex or as simple as you like. So you can add a ton of firewall rules, load balancing features, BGP, etc. So really scale it up as you feel free. So what we're going to do is we're going to drop into our NSX environment. I just want to show you that we've already defined an underlay and an overlay transport zone. And we've already prepared our edge cluster with 2 edge transport nodes. Okay, so now let's jump into Terraform. So I've got a decommissioned area and I've got a provisioned area. So the decommissioned area have all the files we're going to use today. And then the provisioning and the provisioned area is where we're going to drop into and build out this environment. So what I'm going to do first is I'm going to make sure I'm in the NSXT provisioned area. Okay. And then I'm going to bring in our service definition and our authentication Terraform files. So .tf Terraform file. So I just want to point out the authentication file defines the provider. So what we're going to do is we're going to form a Terraform init, and that's going to download the latest NSXT provider for us. And then it's also going to authenticate with our NSXT manager. So let's drop that there into the provisioned area. We're also going to define a few definitions. So one thing I mentioned before was the edge cluster, which was built up of those edge transport nodes. And then we also have our transport overlay, which I pointed out at the beginning. So let's drop that into our provisioned area. So let's perform a Terraform init. And what that does is it initializes it and downloads our NSXT provider. So we have NSXT 2.1. Okay, so now one of the commands we can use is we can use a Terraform plan to say, check my Terraform files, my .tf files, and see what needs to be provisioned, or what Terraform believes it should be provisioning on this new environment. So at the moment, it's nothing. So let's switch back to our NSXT manager, and we'll click on networking and our topology overview. So I just want to show you in the topology overview, we have nothing. So there's no networking elements there. Okay. So now what we want to do is we want to create our segments, as we said first. So we'll look at the dev segments. And what we want to do is we want to create our web, our app, and our DB segments. And we'll have the IP addresses defined here. So what we're going to do is we're going to drag our dev and our prod into the provisioned area. So prod is very similar to the dev. You can see the DB, the app, and the web. And now what we're going to do is we're going to clear that, and we're going to do a Terraform plan again. And what it's going to do is it's going to check those Terraform files, and it's going to say, out of those Terraform files, what do I need to create? So it's found 6 things it needs to create, which are the 6 segments. And if you go up here, you can see the green plus icon showing that we want to create each of these switches. So the plan is essentially just asking Terraform what it feels it should create. But now what we're going to do is we're actually going to create it. So we're going to do the Terraform apply. And what this kind of does is run through another Terraform plan just to make sure there's no difference from the last time you planned to now. Again, it's gone through those segments and it wants to add those segments. It asks you, do you want to continue? Yes or no? Obviously, we want to continue for the purpose of the demo. And we go through, and in a few seconds, we've added 6 segments. So if we switch back to our networking topology and we do a quick refresh, we can see we have 6 segments nicely deployed. Perfect. Now what we want to do is we want to build out our T0. So what I want to do is I want to build out that dev T0 and I want to build out that prod T0. So the first one is the dev T0 and we put that in an active standby state. And the second one is that prod T0 and we put that in an active state. So let's drag that into our provisioned area. It's in there, that's perfect. And then what we're going to do is we are going to do another Terraform plan. So when we do a Terraform plan, what it's going to do is you notice it refreshes the state. I'll scroll back up here now. What we're going to do is it refreshes the state for the segments. There's no changes, so it doesn't register any changes, so it doesn't want to do any changes. And then what it does see is the new files for the T0s, specifically our dev and our prod T0. So what it wants to do is it wants to create those T0s. So before we did that Terraform apply